Okay. Yeah, I should be streaming. I don't really know. Let me check. Alright, yeah. Okay, so for anyone that doesn't know me, I haven't streamed in a very long time, but my name is Aidan Andrews. I'm a current junior at University of Illinois, Urbana-Champaign, studying physics. I also do AI research through UIUC and then also at UC Berkeley. Focusing on robotics right now. I'm doing humanoid robotics at UIUC and low-level control at Berkeley. I have a Physics 435 electromagnetism exam tomorrow, and then a classical mechanics exam on Thursday. And so I'm going to be studying for that. And then I also have a quantum information exam this week, but that's later. Okay, so I haven't streamed in a while, so I gotta get the music back. And then I have multiple camera angles this time. The hell? Yeah, bro. It's been a while since I've streamed. Okay. So I have multiple views. I gotta make sure the music and stuff is all good. It's pretty quiet. I'll turn the music up just a little bit. Okay, there we go. I have two monitors, but it's a little weird, so I gotta be really careful of how I show my screen, so. Okay, let me set everything up first. How good are the grades? Well, school just started, so well, actually it didn't just start. It's been like 2 months, but I've only had like 2 exams and they went pretty well, so I guess it's going well. My roommates are asleep, so I kind of have to be a little quiet. I started the stream a little late. I was gonna try to start like a little while ago, but I had to go to the gym and then get breakfast, so it took a little bit longer than I thought. Okay, now how do I get chat over here? Oh, there it is. Perfect. Did you move to a new place? Yeah, I did. Or like this year I did, but yeah, it's my first time streaming in this apartment. Okay, so I've got a lot of confidential stuff open on my computer, so I just gotta close all these things. so I think I'm gonna go in reverse order of the homeworks and do them all. When does homework 5 do? I already submitted that. Okay. Let me do something real quick, actually. I'm actually not doing that today. Yeah, see, like that can't be open on this. I have Slack open, bro. I know how I can fix this. That's exactly how I can do this. Just leave that. Damn. Why is this solution so long? I'm just gonna keep that in there. Fine. Okay, so I'm just gonna redo this homework assignment. So Mr. Big. Well, I actually have all the homework assignments in this LaTeX file, but stuff's honestly pretty straightforward, so let's get started. I think I'm gonna turn off, hold on, let me turn off autocomplete. Mr. Andrew. What's up, bro? Bro changes his username and profile picture every single day. Yeah, I know it's you, bro. There's only like 3 mods, so I know which one's you. Okay. Okay, so we're gonna use method of images, and okay, I'm just gonna solve this. I'm not even gonna explain because I've already done that. Okay, so we're gonna have 3 forces here. We want to charge on plus Q, force on plus Q. Okay. So in general, well, it actually doesn't matter what we integrate or sum over. Let's just do I to M Q. That's it. Okay, so I'm not even gonna write that out. So let's find the charges first, or the electric fields. The electric field from point charge is equal to radially outwards. So well, actually, we know these are all gonna have a Q over 4. Okay. Right, that's what we can factor out. Yeah, I think so. So like from, wait, hold on, the E field from both, okay, this is gonna be Q squared actually. Okay, and then we'll just do -2 over D squared, so 2D squared. And then we have mirrored charges at, this is going to be +2 at a distance 3D plus D, 4D. And then another charge of -Q at 6D squared. SB, what's up, bro? My school getting serious now, bro? Yeah, I know. That's what happens, bro. Long time no see. Yes, long time. New crib. Yes, new crib. Did you change keyboard? No. I'm still using Newfie Air 75. I also have a Keytron. I also have my Keytron K2, but I don't really use this thing that much. It's too big. Pause. This is. Let me just get a calculator. Oh, we can actually factor out the d squared as well. This is going to equal 29 over 72. This is going to be q squared. This is going to be d squared. And this is a vector, right? Yeah, we want the vector, so this is going to be in the z direction, and we can actually just put it in the minus z direction. Okay. That should be right. Let me check. Where do I have the answer? Up here. 29 q squared over 72 d squared 1 over 4 pi epsilon naught in the minus z direction. Yeah, right. Please simplify that bracket. What calculator do you use? I'm using this calculator. It's a TI 30X Pro. But I also have a nicer calculator. Let me grab it. Since I'm in like the higher classes now, we don't really get to use calculators anymore, but back when I was able to use calculators on exams, I'd use this thing. So nice. The TI Inspire CX2. Bro, it's literally like a phone. There's no Wi-Fi there. Shit. Drop my Rubik's Cube. So no Casio. Casio's not really that common in the US, so I don't use a Casio. Texas Instruments is like much more common here. Yeah, I heard Casios are good though. They use them all throughout like Asia and stuff. And they're obviously pretty good at math over there, so. Prove that the field is uniquely determined. The charge density rho is given. Oh, this is annoying because this just uses the textbook. It's fine. What question are we on? 3.5. Yeah. just have to use from the this equation directly from the proof for second uniqueness theorem. But I kind of don't want to do that. I might not do this question. We'll come back through and do that one. It's not very fun. This one's also not fun, but I guess we can do it. Find the average potential over a spherical surface of radius r. Due to point charge. Actually, we had to use the textbook on this one too. I just don't remember why. Oh yeah, because they gave us BAV. Surface of R, yeah, centered at R. So we have to integrate this over there. I actually think I'm... No, it's fine. I'll just leave it. Okay. This is over the entire sphere. Forgot how to do that. Case, so we're working in, it's a sphere, yeah, spherical surface, so we have a sphere, so we're going to work in spherical coordinates, so dA is going to equal r squared sine theta d theta d phi. Squared law of cosine, so it's r squared plus, I guess we can say little r squared minus 2, I think it's r cosine theta. Yeah, okay. So then now we just plug everything should just, I think I might have to make a new text document, because this is actually getting like being super annoying. The re-rendering is just making me. What's the error? Lonely item? What's this say? It's rendering, so. Wait, is it rendering? What'd I do? I deleted all this nonsense, right? Because we didn't need it. So what's the error? That's what? No, not quite, bro. Dang, bro, I can't type. On line 307. Line 293. What is going on here? Bro, I don't understand. This should be completely fine. Bro, what is going on? Why am I wasting my time with this? Alright, bro, this is actually annoying. Hold on, let me fix this. You end enumerate 2 times? Where? this is, okay, I need this to be better. Wait, I should have an alias for it. Okay, we really only need physics. They didn't fix any of the indenting, bro. Oh yeah, it did. Okay, good. Alright, so it says I don't end enumerate somewhere. Let's fix this in chat again. Who does that belong to? Oh, the first one? Okay, good. Okay, finally. Now let's resume where we left off. We're here. Oh yeah, I'm reorganizing this. So let's take this. Let's put it here. Let's take this. And let's put it here. And then let's erase this. Because the integral does not depend on phi. So we're just going to have 2 pi. This is from 0 to pi. Okay, let's separate this just for so that we know where things come from. That was all in the numerator, right? Yeah. Okay, this is a pretty straightforward integral. So if we set u to equal r squared plus r squared minus 2 r cos theta, where du is going to equal 2 r sine theta d theta. We're gonna have 1 over 2 r. And plugging this back into the integral. Let's just grab all this nonsense. We're gonna have this is just du sine theta d theta. Yeah. And this is just gonna be u. We're gonna need to change our bounds. We'll do that in a second. We'll simplify everything later. Just leave all this nonsense out here. The bounds are gonna change. We have r squared plus r squared minus 2rr. That's just r squared minus r squared squared, and then the top bound is going to be r squared plus r squared squared. Okay, let's just rewrite this. Don't need a fraction. Just u to the minus 1/2. Wait, plus 1. Okay, it's fine. Yeah. Equals all of this nonsense. And this integral is just going to turn into this. What is it? It's just u to the half times 2. Move this 2 out here. U to the half. Okay, so let's just do this. Okay, so we take this here, and this here. Okay, and we have to be careful. Because this is plus or minus. Yeah. So this one simplifies easily. We can just get rid of the square root. But this one turns into just write it like this. Absolute value. Okay. Oh, they use Z. Oh, it's fine. We can just use R, it doesn't matter. Just change the question. Where's the question? Just a little R. Okay, so we know that R is less than big R. So this equals just this, right? And then so we again have all this nonsense. Let's just remove Robotics cancel. So 2. Okay, now we just have to simplify all this. Okay, so let's get rid of the 4 pi. Let's get rid of the 2 pi. And then we'll just get rid of that too. These 2's also cancel. Big R cancels. Wait, this doesn't look right, actually. Wait, QRR over epsilon naught? That doesn't make any sense. Are we forgetting a 1 over 4 pi epsilon naught? Oh, we are. Yeah, we're forgetting a 1 over 4 pi epsilon naught. Up here. When we plug in V, we have another factor of 1 over 4 pi epsilon naught. Here. Right, because we have this one and then we have this one. So then that just stays. So let's just put that. Wait, but what happens to this epsilon? We should have epsilon naught squared. Let me see the textbook. Oh, there's no epsilon naught here. That's r squared. Oh gosh damn it. It's fine. It's fine. Yeah, see, this is why I shouldn't have simplified this. Okay, wait, let me think. Where are we? Here? Let's just replace this with a r squared. Okay, just bring this down here. And then we gotta think. Or actually, I think this is right. If we just remove this. Let's just put the QR here. And this should be just normal R. That looks right, actually. From r minus r squared to r plus r squared. Oh yeah, yeah, that's right. Oh gosh, damn it. Okay. Yeah, that's true. So then we're gonna have another factor of r. Okay, wait. Now this doesn't. Oh, this doesn't look right either. Okay, wait. Let's just redo this. Let's get this because we're missing that here. this. We have a 2r here, 2r here, 2 pi, move another 2 from the numerator. Let's just get rid of this 4 pi. R squared, R squared. No factor of big R or little r though? Guess not. You think this is right? Where are answers? Let me remove this whole section from this. Oh. Wait, is that why I kept getting those issues? No. Okay, what question was that? This one. Q over 4 pi epsilon naught r. Oh yeah, look, there we go. So my answer is right, alright. And this is... what even is the question asking? Find the average potential point charge inside this area. Okay, so that's V center actually. Let's just write that. And then if we have some enclosed charge, then yeah, we're just gonna have Q over 4 pi epsilon naught r. That problem's done. Let's move on to problem 2. Okay, find the capacitance per unit length of 2 coaxial metal cylinder tubes of radii A and B. Okay. Well, I know how to do this, but I'm trying to think of an explanation. Okay, my acai bowl is getting cold. Holy crap. There's a lot of things in the chat. Please simplify that bracket. Stupid questions. You back at home? This is my apartment. Any resources for the theory heavy stuff? For electromechanical engineering? I don't know, bro. Physics degree. I'm doing an engineering physics degree. How hardcore are they in the US? I think it's not that bad. Ours is really flexible. They really emphasize like the engineering part, which is good. Do you get the LaTeX script for the lecture script as well? I don't really know what you're talking about. Transferring to UIUC, is it a good quant pipeline? Honestly don't know. I know a lot of people that end up doing quant after graduating, but I don't know if it's like got some crazy good pipeline. What classes do you have this semester? You can check my transcript on my website. It has all the classes I'm taking. Oh, do I use a template? No, I don't use a template. I just made this LaTeX file with help of AI. Mikasa, Sukasa, see. A med student doing quantum or electrodynamics. What the heck? Why do you have to do electro? What the hell? Okay, find the capacitance per unit length. I assume we just use Gauss's law. Okay, so let's declare something. So let's set charge Oh, and actually okay, we don't have to use Gauss's law. Just from that equation, I actually know what to do now. It's like V of plus minus V of minus equals... Oh wait, we actually might have to use Gauss's law. Plus minus back E, and this should be dot. No, not dot. This should just be dl prime. We don't need a dot, right? L shouldn't be a vector. But E is a vector, so that's a problem. So maybe we'll just do the magnitude of E. So we will have to use Gauss's law. Is this the correct equation? It's minus E dl, right? Where is this? What question is this? 2.4? It is a dot. I knew it. But they're pointing in the same direction, so... Wait, so L's a vector? Yeah. Okay, so we're gonna use Gauss's law. So let's just state Gauss's law. Oops. So, in either case, I think we only need to consider the E field from... So there's going to be no electric field outside of it. There's going to be no electric field outside of the entire thing, right? Just inside, between A and B. So if we set... Oh, not L, sorry. R. Okay. Then we're gonna have Gauss's law turns into we know E and dA are the same direction. So we're just gonna have EA equals Q over 4 pi, or Q over epsilon naught. We're gonna do a cylinder, except only consider radial. So it's gonna be A is 2 pi RL, 2 pi RL, right? Okay. So then who's plus? A is plus? This is just gonna be dr. Okay. It's pretty straightforward. So, get rid of the integral, and then just get rid of this R. These can be in parentheses, not brackets. So we have B over A. Oh no, sorry. We have A over B. But this is a minus, so this is obviously just use the fact that this is this. Okay. Alright, and then capacitance obviously is just should be Q over V. Capacitance is just Q over V, so this just is gonna be C equals frac. So V is in the denominator, so everything down here goes up here. And we're just gonna have Q enclosed times this. And who's Q on top, so Q cancels out. And then it asks for the capacitance per unit length. So another definition equals C by L equals this whole thing. But we just get this out. Okay. So this question is actually pretty easy. It looks a lot more complicated than it is. Or actually, I bet it looks easy, but yeah. Let me try to. This wasn't working earlier, but let me try it again. Yeah, no, it's not working again. Oh, you think I could use that? Oh, I didn't even realize we're on the crappy Wi-Fi. Because I'm still streaming at 10 kilobits, so it's not that bad. Let's see if this Wi-Fi router has correct port forwarding set up. I doubt it. Wait, I don't have UX play anymore on this. Fudge. Wait, do I have to build from source? It should have a... It might have a homebrew. Let's see. Okay, good. Perfect. Oh no, no formula. Okay. So you do have to build from source. But I swear. Did I reset my Mac? I don't think I did. Because I have to rebuild from source. Where's the screen at? Whoever did the bed did a great job. I made my bed. This is a better angle. It's funny. But why is my camera? This camera's... Alright, bro, this is seriously taking forever. It's wasting my time. Well, I guess I can do this right now, anyways. Yeah, I don't really want this here. Finally. This really shouldn't take that long. Okay, time to see if this... Oh. Oh, bad. Okay, there we go. I got it. There's my screen. There's my screen back, bro. I guess I don't need to get rid of that. So... I just wanted to draw this problem out. Because we have... I mean, it's just words. I don't know why they don't say anything. So we have like these two. That's this onto the XZ. Looking down. Oh, so this will be the XY plane, actually. Yeah. Bro, my nose is so runny. Okay, so this is gonna have some radius. R. Right. So let me think. What does it want us to find? Force. If I remember correctly, I need to. Well, actually, we can just use the standard force. Let me think. Okay, the E field, we obviously have Gauss's law, like everyone knows Gauss's law. But we might, no, we have to use Gauss's law for sure. Just trying to think though, if we use like E pi r squared. Equals Q over epsilon naught. Then we get E equals Q r squared over epsilon naught. The force is going to equal Q squared pi r squared. That doesn't seem right, let me think. This isn't right. Oh wow, my screen's not even updated. I don't think this is right. So I have a problem because if I remember correctly, I was using force per unit area. Bro, I don't want to look at my solutions. I should be able to solve this without any assistance. Okay, because if you think about it, yeah, I swear I used force per unit area last time I solved this question. Yeah, see, what does this come, where does this come from? Wait, what? Can we get the textbook? What question is this? 2.42. Oh, this is a conductor. Yeah, I knew I used a force per unit area, but okay, so this is just a general for all conductors. Yeah, this is because it's electrostatic pressure. Okay. So we can't use Gauss's law then. Okay. Let me write this out. But they actually use like the bulb, which I think is math BF. Sigma squared over 2 epsilon naught. Is that what they said? Yeah, 2 epsilon naught in the normal. Okay, so the force per unit area is magnitude sigma squared over 2 epsilon naught normal to the surface. It's interesting that okay. Then we know like some obvious things like sigma is charge per unit area. So that means that sigma squared equals Q squared. Bro, stop doing that. So let's actually move this. So we can just have an equal sign here. Oh, sorry. Yeah, that's wrong. That's wrong. This is 16. This is squared. And this is to the fourth. So 16 times 2, 32. Pi squared. Yeah. Okay, and so that's force per unit area. So force per, let's just do A, equals, this is just the magnitude, so that means that this equals F equals Q squared over 32 pi epsilon naught r squared. Yeah, because I guess we can be more rigorous. Area in the z direction. Yeah. Okay, well my iPad just like it doesn't update. Oh, there we go. Oh, I guess I could do that. Yeah, so we have force pointing radially outwards. Right? This is force. And then N is also pointing radially outward. But, so this is force equals force per unit area, right? Equals Q squared. What do we say? Q squared over 32 pi dot dot dot. Right? But the unit area between the two surfaces is going to be the area of this. We're only concerned with the z direction. The z direction is just going to be a circle between them, so we get pi r squared. So we get F equals whatever we have. We have it written down already. Yeah. So pi. Yeah, just times pi r squared. Yeah, so this should be correct. So Q squared over 32 pi epsilon naught r squared. Yeah, perfect. All right, pretty sure this question was actually pretty interesting. So we're on to problem 4. Okay, so the solution for A from the surface charge density. Oh, this is so easy. Let me, what homework is this? Homework 3, last question. Yeah. So, we have it here. Dude, this is like the laggiest, like my iPad screen sharing is so bad. It's so laggy. Right, it doesn't even matter what the size of these are because it's a conductor. They can have arbitrary size. So these are point charges, right? Yeah. So since it's a conductor, it will cancel out all the charges so that the field on the inside is 0. And then on the outside, we'll just have some charge Q. Where Q this will give us an electric field pointing radially outwards. Is this a sphere? Yeah, it's sphere. Yeah, it's sphere. And this has radius r. So it's over here. Right. So the surface charge density. So since everything is cavities, like these are all cavities, QA and QB, they have no surface charge density inside, only the surface charge density that like surrounds them. So this is just going to be, as we know, charge per unit area. So the area is all the same. Oh, actually no, the area is going to be different. Okay, so this is minus QA over, these are spherical or just circles? Spherical cavities, so we have to do 4 pi epsilon naught. Oh no, not epsilon. 4 pi a squared. Yeah. Sigma b equals frac minus qb over 4 pi b squared. And sigma r, that's what they call it, sigma r, is going to be positive. QA plus QB over 4 pi a r squared. Okay, easy peasy. What is the field outside the conductor? It's just Gauss's law. This is going to be back E. And you can say this is in the normal direction. Yeah, since it's a surface, we'll just say normal. You could say r hat, but it's usually for a point charge. The field outside the conductor is just going to be Q equals sigma times A, and it's going to be divided by A too. Hold on, because we have Gauss's. Okay. Since A points in the same direction as E, we just have EA equals Q over epsilon naught with Q equals sigma A. Yeah, these are going to be the same areas actually. Oh, wait, so just Q equals QA plus QB. Yeah, we don't even need to worry about that. So we have E equals QA plus QB 4 pi epsilon r squared. Yeah, so easy. Okay, solution to part C. What is the field within each cavity? Okay, that's easy. So there's vac. And these are going to be radially outwards. So hat R. And we'll just denote that as a there. And then this is just the same equation. well, it's a for point charge, so it's kq over r squared. Q is just QA, positive because it's within the cavity. 4 pi epsilon naught r squared. But this is going to be a squared. Okay. It's the same thing for B. Why is it ignoring that last A? Whatever. And it's ignoring this A too. Okay, these are all going to be B's. Within each cavity, what is the force on QA and QB? It's just 0. Everyone knows this. 0 for both. Because F equals QE, right? Where Q is the charge of the victim. I don't know what else to say, like victim, like I guess. And E is the external field acting on Q. Since this is a conductor, there is no external field, or there is no field within the surface. Thus, the only field is that produced by A and B, respectively. Let's just do QA. Yeah, we got it, bro. And these also don't act on each other because they're canceled out. Okay. And then E, which of these answers would change if a third charge? So you say we throw in a third charge QC outside, right? Near the conductor, yeah. So this would change these. These would be some Q star. I don't know what else to say. Q star, where Q star equals QA plus QB plus QC. Well, it'd actually be minus QC. Assuming this is plus QC. And so that would change this electric field. This would change. But it wouldn't change either of these. It would change the surface charge density. It would change the electric field produced by the thing. Would not affect either of these. Which is actually strange. Wait, oh, within the cavity. Oh no, it's not strange. That makes sense. Wait, actually, wouldn't you have an accumulation of plus QC charges? Well, I I know the answer. The answer is only sigma r and change. This is big R. Oh, that's actually just like to note this is big R as well. Yeah, it's interesting that what was my explanation last time I solved this question? Well, let's first make sure my answers are correct. Yeah, obviously. Yeah, n hat there, it's the same. I actually wouldn't say n hat. That's not really that proper. Yeah, obviously. Okay, so I didn't even give an explanation last time I solved it. So let me ask the AI. That's part E, right? I don't know how to. That's not right, is it? I don't care. Wait, wait, bro, can we spell words correctly, please? Thank you. Okay, I don't even care. I don't care how to spell words. I don't care. Right, like, if we have some Q star here, then shouldn't we have like QC accumulating here, right? Or is it only on the surface? Oh, they might only accumulate on the surface, actually. Yeah, we might have actually QC all the way over here, not on the cavities. The cavities will remain the same. Okay, I think that's the reasoning, actually. That the QCs go over here. Because a conductor, like, charges should accumulate on the surface, not within. Let's see what it says. Yeah. Okay, fine. Yeah, see, this is exactly what I just said. The conductor's electrons move to the outer surface, to the surface. Yeah, exactly. Yeah, okay. Makes complete sense. Let's move on. Yeah, so that question's done. Problem 3. Where are we? Problem 3. Okay. Yeah. Okay, good. Okay. Yo, what's up? Just popping in to say hi. What's up, Diamond DF, bro? How you been? Okay. So the shell. So the sphere is a conductor of radius r carrying charge q. A thick concentric. Okay, another conductor on the outside. And a radius a out of radius b. The shell carries no net charge. Okay. Find the charge, surface charge density at q. Alright, let's see. Okay, we're gonna assume that Q is on the surface. Bro, me too, Diamond DF. One more semester after this one and then we're done. Well, hopefully for me. It's probably more determined for you, but trying to graduate as a junior is actually like gosh damn it. I need, look, this is the total required credits to graduate is 128. Right now my plan is 128 on the dot. So, if I drop a single class or anything, like I won't graduate. I won't graduate in the spring. Like even one credit. So I'd have to take like a summer semester or something. But I should be fine, honestly. I have some wiggle room. Yeah. So. But congrats, bro. I'm almost graduating. We're almost done. Yeah, just one more. That's what I keep thinking. Is like, bro, just one more year. Like, I can't drop any classes. Like, I just gotta thug it out. But I want to go to grad school too, so I also got to get good grades. Although I don't think they rescind at grad school, so I think I should be fine. Hope you can do it. Thanks, bro. Well, maybe he's talking to Diamond DF actually. I hope he can do it too. Yeah, you're gonna apply to grad school soon or what? Yeah, I'm applying to grad schools right now. I'm applying to 3 grad schools. What's the GPA looking like? I have above a 3.9. So, it's not the best, but it's pretty good. How was Japan? Japan was fire, bro. Okay, can I solve this problem, please? Bro, what just happened? My screen's frozen, bro. Yo, Mac OS, bro. Is this Mac or is this Cursor? It's Cursor. Whatever. Not the best. Yeah, it literally is not the best. Like, by definition, it's not the best. It's pretty good. I worked hard for it, but still, it's not the best. What's good, bro? Binary Brainbow. Why is your username a UUID, bro? What level of encryption does your username have? A homework assignment that covers the first 7 weeks of material? Bro, I low-key just saw someone sent me a meme. It was like me at 11:59 realizing why the professor gave us 3 weeks to work on this assignment. That's facts. Those assignments are so hard, bro. I had an assignment, we had like 2.5 weeks to work on it. I started it the day before it was due. I was so cooked. Yeah, let me know which one you end up getting into. Yeah. good luck in your journey to grad school, A Cat Without Brains. Do you start regular lives now? No, not no. Yeah, definitely not. But yeah. I mean, bro, let me show you my schedule. Let me not leak my emails out. Like, this was this week. Hold on, wait, I can't see my screen actually. This was this week, and then like next week I have 2 exams. What's next week? This one. Exam Monday, Thursday. I actually have an exam Friday and Sunday. But like, I really just don't have time to stream, like, because all these classes, like, I actually have to go to them, or like my meetings. It just doesn't. Streaming just doesn't really work out for my schedule. I could stream on like Friday, Saturday, Sunday maybe. But since my week is so busy, I'm usually Saturday, Sunday, I'm doing everything that I was supposed to be doing during the week. And then I also have like I guess I can do homework assignments on stream, but... Okay, I gotta solve this question. I'm slacking off. Okay, surface charge densities, it's R, A, and B. Yeah, there's gonna be... Yeah, for some reason I'm thinking there's gonna be a surface charge on all 3. Right, because we have... inside of it. I guess we can draw another circle on the outside. Right, so we have some charge Q. So this is carrying a charge Q all along the outside. So we're going to have an E field, obviously radially outwards. But then we're going to have no E field out here, right? Because we have a conductor surrounding it. Wait, is that how that works? Shouldn't we actually have an E field like this, pointing radially inwards? Because like, if we have Q here, then we're gonna have like minus Q along the inside of here, and then a positive Q. Oh, so that's actually gonna be radially outwards. So then we're going to have surface charge densities for all of them. We're going to have sigma equals Q over 4 pi. What are the radiuses? R squared. It's the same as the last question. It's literally the same as the last question. Like all the... What are we doing? inside one. Minus q over 4 pi a squared. A squared? I guess. Yeah, I guess we're just measuring from the origin. Fine. This is going to be q again. 4 pi a squared. I thought it was supposed to be, I remember there was one that was 0. It's fine. Find the potential at the center, so use infinity as a reference point. So we know obviously like v of a, no, v of b minus v at a is equal to minus int a to b of e c dot what is dl? No, dA. dA? No, dl. Wait. D what? Oh, this is way up here. Oh, it's before work. It's before this. Yeah. Yeah, it's L. E dot dl. Okay. So we're going to the center, which is at 0, and we're coming from infinity. Okay, and we're gonna break this down into a bunch of integrals. And E dot dl is just EDR. So the first one, okay, so to go from infinity to 0, we first have to go from, to go from infinity to 0. So the first is going to be infinity. To b, right? Minus, we have another minus. Oh, sorry. I don't need all these minus signs. What is the error? Oh, because I have these. Okay, infinity to b, then b to a, then a to r. And then technically, like, we do have one more from r to 0, right? Well, not that close. But let's actually put this, make this bigger. Wait, how do you do the line with 0 later? You know what I'm talking about? Like to cross out a line? No. Yeah, like this. Like to cross out. Yeah, like that. Yeah, it goes to 0. Yeah, this. Slash cancel to 0. So cancel to 0. Yeah, I probably have to include some package or something. Minus. Let's put this here. What is this? So, yeah, this one goes to 0 because it's a conductor, and A to B also goes to 0. Wait, why does it say B to A? Oh, because we're going from infinity to N. Yeah. Okay. How do we do this again? /cancel 2. And put this one to 0. And then just delete this. Right. B to A cancels, or it goes to 0. R to 0 also goes to 0. Because they're both whatever conductors. So this is just going to equal minus int b to infinity. Let me just copy this whole thing. And I'll just erase everything that I don't need. So I erase these two. The E, so this is going to be dr, and the E at radially outwards from B is going to be that from Q, which is from Q over 4 pi B squared. Yeah, so charge is just going to be Q. Wait, how do, okay, so the 4 pi B squared stays. Yeah, K, yeah, 4 pi epsilon B squared, and this is going to be with QB. No, just a Q. They're all the same. Right, because we have Gauss's law, right? E dot dA. Obviously, A and E point in the same direction, so it's just EA equals Q enclosed over epsilon naught. Q enclosed is just going to equal little q. And then A is going to equal 4 pi B squared. Yeah, so E equals 4 pi, yeah. Little q over 4 pi B squared. Okay, and then the same is like literally going to be the same exact thing for this one. This is from R to A, so we're going to have the radial outward E field from Q as well, except this is from big R. Oh, well, oh, sorry. Yeah, so A is not B squared because this is the area of our Gaussian surface. So like we define some Gaussian surface along the outside. This is going to have radius little r. So it's little r squared. And that's what we integrate over. Yeah. So these are pretty trivial integrals to solve. Let's factor out some stuff, like a minus frac q over 4 pi epsilon naught. And then so this is going to be, or actually let's do brackets. Oh, we actually have two lame integrals actually. I actually memorized the answer, but I'll solve the integrals actually. Oh wait, no, this is in the numerator. Wait, hold on. have to... Oh, right, okay, sorry. Okay, this is easy. It's just minus R2 minus 1, right? From A to B. So the minus will cancel out for all of them, right? So we'll just have such frac. So for the first integral, we'll have 1 over b minus 1 over infinity, and I'll just, whatever, do that later, plus frac 1 over a, no, 1 over big R, minus 1 over a. Okay, this is obviously 0. Okay, now let's see, does this make sense? What is it asking? Yeah. Yeah, the 1 over a should be the only minus, yeah. Okay, so let's move on. Now the outer surface is grounded, potential set to 0. Okay. So, get this Gaussian surface out of here. So say we ground the outside, right? We're gonna ground it. Right, we ground the outside. So this charge Q that was here is gonna go into the ground. So we're no longer gonna have a charge Q on the outside. So we're not gonna have an E field pointing outwards. Right? So the answers to A change accordingly. Yeah, this is actually really straightforward. So in A, backslash sigma B is gonna equal 0, right? Because there's gonna be no charge at B. There's gonna be no charge on the surface. And then if the charge enclosed is 0, we'll just say because, no, it doesn't have a definition. And B, so this integral is gonna go to 0. Let me get it canceled to 0. This, before it yells at me. This one here, right, this integral here is going to go to 0. Yeah, so where's our final solution here? V equals, and all we're gonna do is that. Yeah, that should be correct. Let's see. Did we not check my answers to 4? Thought we did. 1 over R minus 1 over A, easy peasy. 1 over B plus 1 over R minus 1 over A, right? Sigma B equals 0. Q over 4 power squared, A squared. Are you using a 27-inch what monitor? The one in front of my face is I don't know what it is actually. It's 30 something, 36 maybe. It's pretty large. When I watch like stuff on here, like I have to like sit back because it's too large. This question we're not answering because it's like infinitely long. But it's also like common sense. Like I'm just verifying the results of the textbook. Alright, we choose a Gaussian pillbox. Ignore the sides, obviously. We only take the normal vector pointing up from the area. Sigma over 2 epsilon naught. It's like standard. It's the same thing. Bro, when I was doing all of this yesterday, it was actually so annoying. I was really verbose though. There's like a lot of text here, which is nice. Oh my gosh, this was so bad. I hated this. Oh wait, actually this is easy. This is what I just did. I literally just did this integral. Yeah, I just wrote everything out here for some reason. This is the integral I just did where I forgot like all my terms. And I had to like redo the whole thing. So okay. So problem 1 then. My cylinder drawing. Find the potential on the axis, so at xc equals 0 of a uniformly charged solid cylinder, a distance d from the center. The length of the cylinder is L, its radius is r, and the charge density is rho. Result to calculate the electric field at this point. Okay, so this tells us immediately that we're not using Gauss's law. Assume z is greater than L over 2. That's fine. Find the potential on the axis. So no, we won't be integrating the E field, so we want to find the potential first, so should we use Poisson's, right? Poisson's equation. What is Poisson's equation? Backslash Navier squared V equals frac. What is that? What is that? Falling dot SEQ? What? What is that? Let's just use something we know how to. This is rho over. This is literally on the cover of my textbook. Or actually, I think it's Laplace's equation on the cover of my textbook. Oh no, yeah, it's Poisson's equation. Oh, minus. See, I got it wrong actually. Yeah, minus. Okay, Poisson's equation here. Does it want us to actually like figure this out in terms of? Okay, if we have rho equals, rho is the surface charge, no, the charge density, not surface charge density. Frac, so this is just charge over volume, which our charge doesn't tell us, so we'll just assume That's charge Q. Over the volume of a cylinder. Wait, do we have to... I'm trying to think if we should just keep it in terms of rho. What is your theme in cursor? Dude, I don't know what's wrong with my cursor. It's like not working. Oh, because I didn't open anything. My theme is somewhere here. This is my theme. Why not dark theme? I don't know. Well, one, this PDF looks terrible in dark theme. Wait, this is ugly, bro. This is a bad dark theme. Has bad syntax highlighting. I have no problem with like dark themes, but Visual Studio Dark. Yeah, still the syntax highlighting sucks. What about Dark Modern? Yeah, it still sucks. Let's go back to my default. Bro, I love light mode, bro. Use material theme? Is that a built-in theme? Or? Is Calc 1 hard? Here it's not hard. It's pretty easy. But if you're not locked in, then that class can F you up. Okay, I'm just confused. I mean, we know we're gonna have some sort of integral. Because it wants us to solve... I can do Gauss's law first, but it wants us to calculate the electric field after. Look at all these equations, man. Oh, you know what? Maybe we should use this equation. Yeah, no, that's right. Yeah, that's right. I'm wrong. It's not Poisson. Don't use Poisson's equation. Okay, this just is from the what was it? It was V equals frac 1 over 4 pi epsilon naught int of frac rho over dr d tau which in our case, d tau is going to be r squared. Wait a minute. No, not r squared. Wait, why do I think it's, oh, you know what we have to do? Is we have to find the potential from a disk that's, yeah, gosh damn it. Okay, I'm gonna have to draw this out. Because that's what we're integrating over. To integrate over the volume. Oh, I was looking at the wrong problem as well. Okay. Let me pull up my iPad. So, right, we're gonna have some. It's actually better if this is like flipped. Let me just flip this. Don't move it, just flip it. Oh, that doesn't quite work very well. I need to flip this. Okay, let me just flip it like this then. We'll just fix everything afterwards. I need to erase just this. Whatever, bro. So we have this thing at a distance z, whatever. Like, we see that this disk. Like, we're gonna have all these infinitesimally small disks with charge dq, and these are the only things that will be acting with electric field on z. Like, all the force acting in the r hat doesn't matter. Like, we don't care. Like, if we set this to be the z-axis, this to be the x-axis, we only want z hat. Okay, so if we have one single disk, the electric field from a disk is what? It's EA equals Q over epsilon naught. This is pi. Right? This is the E field in the Z direction. And now we need to integrate that. Wait, we should have a dependence on Z. Shouldn't we have a dependence on Z? Wait, I'm actually kind of a little lost here. Wait, let's make this DE. And then this, we could say DQ, right? No, it doesn't work. Gosh damn it. Why don't I know how to solve this? Oh, maybe because I'm doing it wrong. Maybe we should just ignore the E field for now. Let's just worry about the potential. Right, we have... This is DR? D tau. Yeah, that's the problem though, is because we have this D tau. Should we just integrate over? Should we just treat R as a constant? What are you guys chatting about? How is your chess progress? Do you still list a kid? I haven't played him in a while, but my chess progress. I play a lot of Blitz, but I don't really play anything else. I don't have time. My entrepreneur, is he doing his homework in Cursor? Bro, Cursor is life, bro. Is this Gauss's law? No, it's not Gauss's law. We can't use Gauss's law because we have to find, we only have the surface charge density, or not surface, just the charge density. And it wants us to find the potential first and then use Gauss's law, or use the relationship between potential and electric field to find the electric field. Yeah, text is better than Markdown, but yeah. It depends on the use. I like Markdown. It's much simpler than LaTeX, but yeah, LaTeX is way superior for math. It's not even close. It's much easier to write research papers if you have like experience with LaTeX. So I write all my notes and stuff in LaTeX. Like, look, these are my lecture notes from this semester. It's so slow, bro. This is why Cursor keeps freezing. Okay, I don't even have my hand on my mouse anymore, so I don't know why this is doing this. This PDF is too large. Okay, well, I can't. Yeah, Cursor's frozen. Okay, there we go. But like, I write all my lecture notes. Hold on, let me find like a good chapter. Yeah. This is work. All my lecture notes are in LaTeX. It's so fire. You can't do this in Markdown, bro. You can also handwrite it, but there's handwriting, then you don't have and it's not easy to use. And then also like what I just did earlier with ChatGPT. No, not this. Like, bro, I just put the question into ChatGPT and like it knows LaTeX really, really well. And so I was like, great question. Like, nice, Griffith. Yeah, Griffith is fire. This textbook is great. Mac problems. It's not a Mac problem, bro. It's because this PDF is like 300 pages long. Cursor's not supposed to open like 300 page PDFs. My quantum mechanics or quantum information stuff from last semester is the best though. I think it's here. Yeah. From Physics 370. This is like I built this last year and then I've just used this one as like a template for all my classes. But this is my LaTeX notes from last semester. It's really nice. I love LaTeX. Okay, I need to do this question. I think though I need to move on, so let's look at what I did when I solved it yesterday. If we look at the cylinder from point C, we see a disk of radius R with a thickness L, which we do not know to deal with, so instead we think of the cylinder as a collection of infinitesimally small disks. Yeah, that's what I just said, bro. We can then integrate over the cylinder, treating each component as a thin disk. We will define a variable x that will measure the distance from Z to the disk of interest. This will be R. Oh, that's my, okay, bro, I'm such an idiot. Yeah, okay, because the disk doesn't have a surface charge density, or the disk has a surface charge density, not a volume charge density. So this is dA. Yeah, that was so stupid. Yeah, okay, this is easy. You can just keep it in terms of sigma, actually. We should do, should we do law of cosines? Yeah, so we have to define some distance. Like, I labeled the x-axis, and let me do this, the y-axis actually. So we'll say some distance in x. Yeah, x will measure like the distance between that and the infinitesimally small disk. Because we're gonna have some radius like little r. Because we have to integrate like over the disk. So we're integrating with respect to r only. And then this is just standard. We actually don't have to use law of cosine. It should just be little r squared plus x squared. Right, x is constant with each disk, and then we just integrate over r. Okay. Wait, hold on. This is really pivotal, so I gotta make sure I have this. It wants to do r dr d theta. Which I guess makes sense. Oh yeah, I'm an idiot. Yeah, you can't just integrate over. Yeah, it's area of a two-dimensional surface. Okay, this is easy now. Yeah, you just use u equals r squared plus x squared. Du equals 2r dr. 2. Theta is just 2 pi. Okay, I should be doing this one. Oh, you guys can't even see what I'm writing. I forgot. Okay, where am I? Okay, here. So first, let's find the disk. R dr d theta. We're gonna have a 2 pi, and we're gonna have a sigma. We'll cancel stuff out later. Then we're gonna have our integral. Frac with r over root r squared plus x squared. And this is gonna be dr. What is this? SQRT? Wait, is SQRT not square root? Hello? Oh, sorry. I have that backslash. And no d theta, because we already integrated that. And then we can obviously just use simply use substitution. U equals r squared plus x squared. This is frac 1 by 2 du equals r dr. Let's copy this. This means u to the minus 1 by 2 du. And this is 1 by 2, so just go to this 2. And the bounds are just 0 to r, right? So left. This is going to be from 0 to r. What was our integral again? We had u to the minus half. So I guess brings back another 2. Oh, we gotta change our bounds. Our bounds are gonna change to, what would we set u to be? We said u is r squared plus x squared, so we're gonna have big R squared plus x squared. Oh wait. It's x squared to big R squared plus x squared. So we have square root of x squared. Square root of r squared. Oh, that's what I was missing. I was like, why is this, this is absolute value x. Okay, and now we have to integrate with respect to x. So let's take this whole thing. We'll simplify all the way at the end. Like, let's just keep everything. And this has more complicated bounds. We're going from z minus L by 2 to z plus L by 2. Oh, oops. We'll just go from, we'll go from here, z minus L by 2 to z plus L by 2. Doesn't matter which direction we integrate over, as long as we integrate over the whole surface. Wait, does this give me like an actual stupid integral? Root r squared minus x squared? Wait, why is it minus? Why do I have a minus there? Yo, can someone solve this integral, bro? A squared plus x squared. Oh, sorry. Come on, where's the AI? Oh, here it is. Oh, yeah, right, bro. But that has to be like the most annoying thing I've ever seen in my life. That does look right, though. Oh, crap, and that's indefinite. I'm gonna have these stupid bounds, bro. Yeah, bro. Yeah, bro. We're gonna go ahead and look at this. Like, I already did this once in my life, bro. There's no point to do it again. Let's just make sure I was right. Just sigma over 2 epsilon naught. Root r squared plus x squared minus absolute value of x. Yeah. Z plus L by 2, Z minus L by 2. Yeah, bro, look at this integral. Yeah, right. Chat, are we seeing this? Bro, what the fuck is this, bro? Yeah, right, bro. Yo, that's the biggest steal. No way I'm doing that. Yeah, there we are, baby. Yeah, right, bro. Where am I? Here. I'm literally just throwing the equal sign. Oh, hell nah, bro. It doesn't even fit on one line. Bro, it doesn't even fit on one line by itself. Oh, yeah, it does. That's just, bro, that is the dumbest integral I've ever seen in my life. Z is greater than L by 2. Are we supposed to use that property somehow? And the charge density is rho, use your result to calculate the electric field. Electric field? Yo! You're telling me I'm supposed to take the second derivative of this? Wait, no, it's just the first derivative. First derivative with respect to what, Z? Wait, why would we take the derivative with respect to Z? It is with respect to Z. The only non-zero component is the Z component, so we take the, yeah. Well, that's actually not even correct. That's not a good way of wording that. It's not the only non-zero component. The only component that does not cancel out is the Z component. But the R has no effect on. Yeah. E in the R hat direction has no effect on Z. And the only component, well, because we're gonna have in the Z direction as well, or in the, what I say, that's the y-axis. Like, if we have this disk, we have our point, like Z here. The E field is going to point like this, right? We have all these. And then these can be broken down. Actually, let's do the components this way. Let's just draw the diagram. Right. Let's just close these triangles. It doesn't matter. Alright, we have theta, theta. The Z component, or the X components, I guess that's the Y-axis. The Y components are going to cancel, and the Z components are going to accumulate. Yeah. the components in the x direction and the r direction are not zero. So saying the only component that's non-zero is z is wrong. Why does it say no, bro? Hello? Yeah, let's just copy that answer, I guess, again. Like, I'm not taking the derivative of this nonsense, bro. Bro, you see this, bro? You want me to take the z derivative of this? It's not like that hard, but like with product rule, chain rule, freaking chain rule, quotient rule. Like, come on, bro. Chain rule, quotient rule, chain rule. Like, yeah, all right, bro. Alrighty. Let's skip that. I need to go to the bathroom. I'll be right back. Okay, I actually just realized that I left out a key detail here. So this is actually incorrect, this writing that I have here. This is rho, and we have to use the fact that backslash rho equals sigma dx. And this is the integral, actually. Wait, shouldn't that be an integral? I think we should just say d rho. Yes, d rho equals sigma dx. So then we say no, this is wrong. It's just rho. It's just rho. We're saying v equals, because we're integrating v, we're not integrating sigma, we're integrating v. The integral of v disk. Now we're saying we're saying dV equals V disk. Yeah. And then V disk has sigma, so we have this differential. And then all we have to do is throw an integrand on it, or an integration sign. I think. What did I say yesterday? Yeah, rho equals. Oh, sorry. Yeah, why? This is the wrong way. Sigma equals rho dx. Wait, actually, yeah, sigma equals rho dx. Wait, why does that make sense actually? What are they? Sigma is the surface. Is the charge per unit area. And rho is the charge per volume. Times the area, the volume per area. We're saying the volume per unit area is dx. Unit volume per unit area is dx. That actually doesn't make any sense at all. I think this is why my notes are in LaTeX, bro. Okay. Let's see what this guy says. Dude, my acai bowl is like warm, room temperature. Is Mac Tahoe good? Yeah, it's fire, bro. How's your research stuff going? It's good. You finished your Java assignment? Congrats, bro. I want to upgrade. I have no problems with Sequoia. Yeah, Sequoia was great. I just upgraded for fun. Do you do AI research? Yeah, I do. Long time no see, indeed. Wait, why does it say DS? What is DS? DS is the thickness? Radius R, the charge. dr equals r dr d or dA equals r dr d theta. Yeah, obviously. dq equals rho times the volume dA ds. Oh, dq dA is sigma. It's a pretty smart. Yeah. That's where my confusion comes from, is because I use x. I defined x as the distance, but it's also the thickness. Wait, how are you gonna integrate over ds? We don't have s. Why does he want s? No, I'm gonna keep it as x. I mean, that's what the thickness is. It's with relation to this length here. Yeah. Okay, we're gonna keep it as dx. Okay, let me be more rigorous though. Okay. Where did I write that? Okay. Now let's integrate over the cylinder. We know backslash sigma equals frac dq over dA. Right? The charge per unit area. Also, backslash rho rho equals frac dq over the volume d tau. Okay, so that relates sigma to, okay. And so this says backslash sigma, equals backslash rho times d tau dA. Right. It's the volume per unit area. Is the thickness? And we're just saying. Wait, hold on. What is this thing I said? Dude, I need to eat this acai bowl badly. It's literally like, you know. I've taken like one single bite. Damn, bro. Just got thinking about. By definition, yeah. For a thin slice of the cylinder, a pillbox disc of thickness dx taken along the axis, its volume element is d tau equals dA ds. Oh yeah, I wrote d tau dA, didn't I? Yeah. And so you're saying yeah, I guess that is what volume is equal to. But that's not volume. Oh yeah, cause yeah, okay, it handles it. Okay. We know sigma equals dq dA, also rho equals dq d tau, so sigma equals rho d tau dA. By the definition of volume, dA dx, so we're saying d tau dA equals dx. So we substitute dx back in, we get rho, or sigma equals rho dx. Yeah. Perfect. Okay, now we're supposed to move on. Problem 2. Okay, this question should be pretty straightforward. They give us all these equations. Equation 2.27, 2.30, find the potential V at a distance E above the center of each charge distribution for each case. Compute the electric field E equals minus delta V. Dude, this is annoying, because I could just use Gauss's law and then integrate it to get V, but they're making me find V first. But I mean, these integrals are really straightforward, so. Okay, so for A, I don't even have to do anything. Bro, I don't even have to do anything. The equation's right there. Wait, these are gonna have the exact same distance and the exact same charge. Right? Don't we just get this? We have summation, so we have Q over R plus Q over R, right? Because our R should be the same for both. So R just equals root D squared plus D by 2 squared. plus or minus d by q. I just saw your reading list, and you're really into robotics. Yeah, I am really into robotics. I'm doing research with UC Berkeley and UIUC for robotics. And that's what I'm applying for a PhD, is in robotics. What's your IQ, by the way? I don't remember. I did take an IQ test once. I think I sent it to the Discord, actually. Some lame IQ test. It was like some random IQ test. Let me see if I can find it. Why am I wasting my time with this? Why am I wasting my time? Whatever. Let me just find these messages, bro. Can I search by like date? No. Damn, bro, we send hella messages in the Discord. Oh, you know I'm an idiot. Oh. Hold on. I don't know why I care so much. I don't really care about. That's kind of trash, actually. Oh, gosh damn it. I just dropped like everything. Okay, from this IQ test that I took and sent to the Discord. By the way, I think IQ means absolutely nothing. But ChatGPT says, oh, I just deleted it. Okay, whatever. So from this IQ test that I took in April, it says that I have like above 150. But it was like a 15-minute test. It's so stupid. I think that's, yeah. But IQ to me means really not that much. Straight into PhD? Yeah, I'm gonna go straight into PhD. I thought you wanted a PhD in ML. Well, it kind of is in ML. Like, ML is the underlying, like, science behind AI as a whole. And AI encompasses definitely, I mean, I'm getting a PhD in, like, AI pretty much. The application of AI that I'm interested in is robotics. But it's still AI as a whole. Like, we're still using the same transformer models, diffusion models, stuff like that. It's like the same. Yeah, I think Ollie's right. It's passion does go a long way. Yeah, ML is integrated in robotics, yes. What you need first and foremost is intelligence. Well, I actually think that's not true. I mean, that's like saying, like, to play football, you need, first and foremost, you need the skill to play football. That doesn't really make any sense. It can be developed, right? I mean, Lamine Yamal didn't just wake up with like some, well, actually he kind of did because he's insane. But I mean, like, you can develop your intelligence in a sense. Or I do agree that, like, intelligence is pretty fixed, but your ability to use your intelligence can be developed, right? Like, you could be really intelligent, but you just don't have the tools necessary to use your intelligence correctly. And those skills and tools can be developed, like, if you're just pursuing some passion that you have. Bro, I said, Ollie, that IQ test is stupid. You can look in the group chat, or no, the Discord. It's from, the message is from, gosh damn it. How do I find this message again? What was it? What did I look up? Oh yeah. Oh yeah, from Aidan Andrews. The message is from 4925. So, what month is that? April? April 9th, 2025. How did you organize your studying? I use Notion recently, very recently. I usually don't, but I have a task tracker now on Notion. With all my done tasks. It's fire. And I track all my exams. I don't really use anything else on here though. Kind of just remember, just use my memory. Most days I forget to even check Notion, so I just use my memory. But for assignments, I really just go here. I have this folder, and I just look through all these. I go, what assignments do I have? Let me change this actually to, wait, this should be the right month actually. I'll just look here and click on whatever class I need. Oh, what do I have to submit today for this class? That's really how I do it. Oh, can I close all these tabs? Yeah. Damn, I'm really behind on. Yeah, Lamine Yamal is an exception. Yeah, that was a bad example. Yeah, he literally like. I don't even know how he's so good at football. It makes no sense. Or soccer, whatever. Bro, Blitzer, I'm 100% aware of my blessings. Like, I'm very grateful for what God has given me, and I'm not claiming that like this is like my situation is a result of only hard work. It's obviously not true, right? Like, I could have not been interested in physics or not been interested in machine learning and AI, then I wouldn't have pursued those things. Or you're saying if I had a lower level of like baseline intelligence, then I wouldn't even have the intelligence to pursue these things. So I'm grateful that all those factors kind of lined up to give me the ability to study what I am. But that being said, like, hard work does go a long way. Like, some people may not have to, or may have to work like a lot harder than I do to do some things, which kind of sucks, but in any case, like, I believe that you can achieve your goals if you just have the right, character traits to go and pursue them. Yeah, my luck and like what I'm grateful for is mainly the lack of setbacks that I've had. I have like just inherently in my life, like I have had all these lucky things happen to me that have minimized the amount of like setbacks and things that I have to overcome to achieve my goals. But that doesn't mean like those things can't be overcome, right? Like, if you're less intelligent, like, you can still get to the same level that someone who is deemed as intelligent is. But you're gonna have to work harder, and you're gonna have to have more passion, most likely. Right? So like intelligence and like the baseline stuff that you get like just from being born do matter a lot, but they can be overcome nevertheless. Techniques to be more efficient, not streaming, because I'm just reading chat and not doing any work. He's gonna tell you all this BS about Notion or whatever, which is totally irrelevant. Yeah, it is totally irrelevant. Yeah, I don't really use Notion. You're correct. I just happen to have it. I use it for meeting notes. That's like the main reason I use it. But I mainly just remember the stuff that I have to do, which is a gift. I also don't really take, like, I have these lecture notes, but I stopped taking lecture notes. Like, I also don't really take notes in class. I just, like, sit there and stare at the board, and I don't know, for some reason I just tend to remember the information really well, which I'm also grateful for. Binary Rainbow and Ollie are obviously gonna start beefing again. Just gotta Goggins it. I mean, yeah, honestly, like David Goggins is kind of a perfect example. Like, he was fat, which someone would be like, oh yeah, he has a disposition to like being bad at athletics and hard physical contexts. Because he's fat, right? But he overcame that, and now he's doing like these crazy things. Like the same way you're saying like, oh, intelligence is something that like you're born with, and you're either like can pursue these crazy goals or not based on your intelligence. I feel like it's wrong, because like David Goggins, you look at him, he was fat when he started, and then he ran 100 miles in like 107-degree weather, like a 9-minute pace. Right? Like he's doing the impossible, and he came from like a very bad situation. Like it'd be easier for me to go do that, right, than David Goggins when he first started, because I'm in better shape than David Goggins was. But he put in a substantially higher amount of effort and work than I did, and he was able to achieve his goals. Which sucks that he had to put in that effort and stuff, compared to like if I wanted to do that starting today, I really wouldn't have to put in as much work. But he still overcame it and did it. Like what? Do you review the information beforehand before lecture? I used to. I've been really bad at it recently. I just go into lecture blank and I just stare at the screen. I just stare at the blackboard until like things make sense. Most times they don't even make sense till after, when I read the textbook. But nevertheless, yeah, I don't really read before the lectures anymore. I used to. It is helpful. Do you enjoy languages like Lisp? I'm not really that familiar. So possibly, but I'm not familiar enough to say I enjoy it or not. Yeah, I would agree. I'm low-key not gonna say your username, but I would agree. I would agree, Kay. Yeah, that's true. Most people do not have that discipline, sheer level of obsession. And that's something you're born with, right? Because, I mean, to run 100 miles, like, to want to do that, I don't have that. Sounds like sounds terrible to me. No, I think going into lecture empty actually hurts my learning. If I read the textbook beforehand, I think I'd be much better off. I want to transfer to UIUC. Oh, I did answer that question, but I don't know if there's a good quant pipeline or has a good quant pipeline. I know a bunch of people who go into quant, CS plus math and CS plus stats kids. Or math stats with like a minor in CS. Yeah, I mean, it's a top school, right? So I think you have a good chance of getting into quant. Well, top school for CS at least. Some of the other majors it's not as high. So. And like it's superficial, but like that stuff does matter. Like going to a top university does matter when you want to get a job. Just the truth. Say hi to Brazil. What's up, Brazil? Yeah, I don't know what's wrong with David Goggins, right? He has some like mental illness or something. I don't know why he chooses to do those things, right? It's actually crazy. Okay, let me do this problem. So we're on what, problem 2 or problem 1? Yeah, I said 1 over 2 pi epsilon naught q over r. Yeah, exactly. Okay, so now we need to find the electric field. Oh my gosh, so annoying. E equals minus W, right? In our case, in all the cases actually, wait, what homework is this? Is this homework 2? Oh, my iPad's on the wrong. In all cases, we can look at this, right? And we can say, this is actually like a really easy way of writing this. You can just go, go like this. But like say we have these E field lines, and there's infinite of them, right? Like they go, oh well, actually they don't go in that direction, but like there's infinite, like it goes radially outwards. But, oh gosh damn it. But they point in this direction, so the Z's are gonna add up. Say this is the X, this is the Z. The X's are going to cancel out, so we only have the accumulation of E in the Z direction. And we know that it is, we use the principle of superposition, but we already used that here. So we can just integrate. Oh, and the point of me saying that actually was because this will just be equal to the partials. Partial of V with respect to Z, right? Which just equals, so in general, like our, oh my gosh, okay, fine, I'll write this out. So R is going to be square root of R squared, which in this case is just D by 2. Z squared, right? And so we're taking the partial with respect to Z, so we just have chain rule. That's annoying. Okay. D by 2 squared plus Z squared, so minus 1/2. Okay, that's 3 by 2. Oh, thankfully the Z by 2 cancels, right? So we just have Z. Oh no, 2Z, sorry, not Z by 2, 2Z. So where are we? Here. This just equals frac 1 over 2 pi epsilon naught. Let's move the Q out here too, actually. And then this is just gonna be, we're gonna leave this in frac, or no, whatever form. Hold on, wait, minus Z here. This is gonna be D by 2 squared plus Z squared. This is gonna be 2 the minus 3 by 2. Oh, my bad. Like this. And this is gonna be in the Z hat direction. And we can actually do minus Z hat direction. And then we can make the magnitude positive. Actually, let's just simplify this even more. We don't even need to have this whole thing at all. We can just have back script R cubed. which makes sense. Kind of. Wait, shouldn't the E field just be superposition of... Isn't the E field from a point charge kq over r squared? So like we have this r cubed. Oh, but we have a z in the numerator. Yeah, we have z in the numerator, so I think it's fine. Yeah, zq over 2 pi epsilon naught r cubed. Oh, we actually have another minus sign. Oh, you're right. This is in the positive z direction. Yeah, this would make no sense being in the minus z direction. What am I talking about? Because we have this extra minus sign out here. Yeah, it has to be in the positive z direction, obviously. Okay, now we move on to the next. What the hell's that? Okay, so to solve B. Oh dang. I think you need to do Pomodoro format streams like JV Schools to not distract yourself while studying. Nah, bro. I don't need to do that. I'm chilling. Wait, why are you doing the problem in code? How the hell you get and you did maintain a 3.9 GPA in University of Illinois Urbana-Champaign? I don't know, bro. Okay, let's move on to the surface. No, the line charge. The line charge, so we have this equation 2.27, right? No, 2.3. This actually is like so easy, bro. So can we just hurry up and get this over with? This is gonna be dr, obviously. Let's just keep this as lambda, right? Yeah, why would we? What's the point of complicating anything? Script R, we can just leave that. What are they bowling upstairs, bro? Doing jumping competitions, bro? Why are they so loud? Okay, wait, this is actually not as simple because that integral is kind of stupid. I think root 1 over a squared plus x squared is what, like 1 by a arctan of something. And arctan equals like some ln over something. ln of something over something. Yeah, right. Yeah, ln. Yeah, see. Do we evaluate that integral? I think it's unnecessary, right? Let's just copy it. Like, cause this This is an integral that I'm just gonna have to memorize anyways. We have 3 parts. Part 2. Why did I say L in this one? I think it's simpler to write R. Oh, actually, no, you're right, it's L. There's no radius. Yeah, because you have this stupid integral, bro. Let me write this out so that it's clearer. What is this? Z squared plus L prime squared. Bro, and then we have to take the derivative of this? Like, I'm also... Yeah, this is unnecessary. Bro, if this was on the exam, I would just use Gauss's law. Like, it's so much easier. Why am I integrating potential to find... Or to take the derivative of potential? That's apparently the derivative, yeah? Yeah. Okay, yeah, I mean, that integral is not even, like, solvable, bro. Yeah, I'm sorry. I can't solve that shit off the top of my head, bro. Hate to breaks. And then let's set up this integral for the last one. And we're gonna just bring the sigma over here. Replace this with a 1. Script R dl. So we're gonna have triangles of different radii. But if we're using sigma, then like we have we're treating the rings individually as a line. So we don't actually need to integrate with respect to theta. Or maybe we do actually. In any case, we don't depend on theta. The integral is only going to depend on r, so let's just write this. And this is going to be backslash rt z squared plus little r squared. The thing is, like, do we have a 2 pi? I just don't think we need to integrate with respect to theta. I mean, okay, let's think about this like with Gauss's law. What would our result be? Like we don't need a theta, bro. Oh, we do. And we have RD theta. That makes the integral like really pleasant, but then shouldn't this be dA and not dL? Where in the textbook do we have dl prime, bro? What question is this? 2.25. What equation Is this supposed to be 2.27? 2.23 or 2.3? Yeah. Oh, it is dA. Yeah. See, why do I have dL? Yeah. Okay. That's why. That's why I was confused. Where is this? dA. Yeah, this should be dA. Yeah, now we know the solution to this trivial anyway. RD theta. Obviously. And we can just ignore the theta because it's just 2 pi. We have no theta dependence. Unless you use law of cosines, but it's not really necessary. And then this 2 cancels when we do our u substitution. Right? So we have 2r. This is going to be du. This r goes away. We're just going to have root u. U to the minus half is just going to be u to the half. Wait, do we need another 2? Yeah, we need the 2 back, actually. Yeah, we need the 2 back, actually. This is no longer an integral. It's from 0 to r. What do we say u was? U is r squared plus what? R squared plus z squared, right? So we have 0. It's just going to be z squared. Yeah, this follows exactly from what we did earlier. This is going to be big R squared plus c squared. This is going to be minus, and then this is just going to be absolute value. Okay. Oh, get rid of the du. It's already integrated. Yeah, sigma over 2 epsilon naught. Wait, but what is this absolute value of z? It seems unnecessary. Oh, okay, because... Wait, no, we're taking the derivative, actually, never mind. Wait a minute. This is not looking good. But that's right, like what I have written is right. Like u equals... Yeah, but like, how do we take the derivative of that? Right, like, is that not an issue? Yeah, okay, good. So my integral's right. But like, 1 by z. Wait, what? Are we seeing this? How's the partial of absolute value of z 1 by z? Is that right? I guess it makes... Wait, that doesn't make sense though. Wait, right, this doesn't make sense, right? Where are like the actual solutions? What homework are we on? Homework 2. What question? 225. Yeah, minus absolute value of z. Oh, it's saying z by absolute z? Oh, that's just saying plus or minus 1, bro. Yeah, it's just saying plus or minus 1. Okay, so the derivative is plus or minus 1. Yeah, that makes sense. Okay. Alright, let's write this out. Where are we? What are we doing? Minus partial z. Let's get the thing in front. This thing. This. Let's get a minus sign out here. Okay, and then this makes sense, right? Okay, so derivative of that is gonna be it's a minus sign. Plus or minus 1 is the same thing as z over absolute value of z. And it's a minus sign. So minus z over absolute z. But our signs are wrong. This also needs to go here. Oh, we don't need parentheses. Yeah, but why are my signs wrong? Yeah, see? Because this should be negative. And then we distribute this negative, so we should have a positive, right? Or like where did like this should be negative, right? Unless I'm tweaking. Why is it? Why did I think it was negative? Oh no, I guess it is positive. Wait, why did I think it was negative actually? I don't even have it. I have a negative here for some reason. Strange. Some strange things are going on around here, bro. Alright, let's simplify this. That's the correct answer. Oh, I forgot to erase the pi. There we go. Okay, let's move on. A lot of stupid integrals going on around here, bro. Where's problem 1? Long coaxial cable carries a uniform volume charge density rho on the inner cylinder. Okay, the total charge is 0. So there's no E field outside. There's no E field outside the cable. There's a field inside the inner cylinder, and there's a field in between. But there's no field outside. easy lemon squeeze. We have some charge. Let's designate like some charge Q here. There's some charge Q on A and some charge Q minus Q on B, right? So we have rho equals minus Q, or no, Q over 4 pi r squared. Oh, sorry, not r, a. 4 pi a squared, or volume charge density. Surface charge density is going to equal minus Q over 2 pi BL. Oh, what am I doing? Yeah, this is also... Wait a minute, but one is a surface. One's area and one's volume. So this is the area, which is just 2 pi BL. Wait, am I tweaking? Yeah, 2 pi RH, yeah. Okay. Because we're not concerned about the sides. So 2 pi BL. Pi r squared h, yeah, that's what I thought. Right, we're gonna choose a Gaussian surface. We might as well choose, oh, okay, L. Okay, so we have, what are we saying? Q enclosed. In this case, let's just put like plus or minus Q. Yeah, saying we have some charge plus or minus Q. Okay, so we know obviously that this is going to be just EA. For A, so we have some Gaussian surface with radius R. So we're going to have E. Wait, in both cases we should have the volume. Yeah, so it's going to be pi r squared L. Yeah, rho pi a squared. Are we missing something? Absolutely not. I remember though that we actually, So that the electric field over a cylinder. Right, we want the volume though, right? No, we want the area. Yeah, we want the area. Oh, we have. I literally had area written down. Why did I write the volume? So it's 2 pi RL. The pi still cancel. Let's just keep it in terms of Q. Equals 1 over epsilon naught 2/3 pi k ls squared. Oh, because you're saying rho equals ks. What's going on here? So I mean, this is right. It's just we're not supposed to have this dependence on length. Yeah, we're working on case B right now. Case 2. That's what I put. Wait, what? That's all you need to write? Okay, I guess, I mean, that's what I have, so. Alright. Alright, bro. Why didn't I do any of this canceling out? Okay. This is easy enough. Wait, where am I? Oh, I haven't written anything. Where am I supposed to be? Here? This isn't problem 1. Oh, I guess it is. Okay, fine. So let me just write. Why did I get confused? Continuing makes sense. Okay. R is less than B. We don't have anything, or less than A, sorry. We don't have anything outside B. It literally says the total charge is 0. So if you enclose the entire thing, like your charge encloses 0, bro. Okay, let's pick a Gaussian surface. Yeah, I'm confused how it's not the same thing. Are you left-handed? Yes. Wait, hello? Wait, my answer is right though. What do we have? Rho a squared over 2r epsilon naught. Wait, how do we not get the same exact answer? Okay, wait, we gotta make sure we are seeing what, okay, we enclose some region of radius r. Or let's just say we enclose some region of radius s. Yeah, our Gaussian surface is still gonna have r. Wait, how, do you see how I wrote r over r? Isn't that stupid? Aren't these different r's? Oh, I guess they would be the same. Yeah, your Gaussian surface would enclose whatever object you have over that same radius. Yeah, it's gonna have the same radius. That's lame. That's a lame answer, bro. Are we sure that's the answer? What question is this? Hello? Homework 2. This isn't actually problem 1. 2.24. Rho pi s over, yeah, how do they get that same answer? Just pi, just rho r over 2 epsilon naught. Oh, I didn't put my unit vectors. These are both going to be in the r hat direction. Just radially outwards. And then obviously, like, okay, also find the potential difference between a point on the axis and a point on the outer cylinder. You do not need to choose a specific reference point. I need to pick a specific reference point? Oh, because we only are concerned with one. Oh, on the axis. On the axis, sorry, not a A. Oh, okay. Let me go A to B. Yeah, okay. From 0 to A, this is what we're gonna have. And then from A to B, this is what we're gonna have. Okay, let's factor out this nonsense. Row. That's it. That's all we can factor out. We're gonna have A squared over R. Right? And then we're gonna have 0 to A. Okay, so we can factor out an A squared actually. Because they're both gonna have A squared. Oh, this is a plus. This might just be 1 by 2 actually, right? Yeah, it's just 1 by 2. Should be. Boom. Easy money. Oh yeah, great. 6 problem homework assignment, bro. They were tweaking on homework 1, bro. I'm just trying to make sure. Oh yeah, maybe I should be checking my answer with the answer key. Not my answers from earlier. Yeah, it's the same answer. Rho a squared over 2 epsilon ln b by a plus 1 by 2. No, we'll go over we'll come back. We'll come back and look over all this stuff. Find the electric field at distance s. From an infinitely long straight wire that carries a uniform charge line, a uniform line charge lambda. Alright, this is super easy. We've done questions like this like a billion times, obviously. So let me just do we even have any pictures for any of these questions? Oh yeah, I guess we do. So I'll actually how do I select all? Select all. No, gosh damn it. Select all. Clear. Oh hey. And get rid of all my pictures. Whatever. We're on this question. Does not matter. I do not need pictures. Right, we have this infinite. Say this goes on forever. Who cares? We're gonna define a Gaussian surface. Nope. Like this. Bro, what shape is that? Like dead ass. Oh, can I not draw just like a... Bro, I'm actually getting tight here. There we go. Okay. Doesn't matter. Okay, so we define some Gaussian surface of arbitrary length L. Doesn't matter. The magnitude of the electric field is going to be the same along this entire wire, and it's going to be pointing radially outwards. So like into the page, out of the page, upwards and downwards. Right, just in the r hat direction. Okay, so we have our Gaussian surface, so let's just use Gauss's law. We know Q enclosed is just going to equal lambda equals the uniform line charge, the charge per length, charge per unit length, lambda L. And in this case, the L that we enclose is just going to be of length L. So this integral is going to go away. We're just going to have E, A, obviously, because A and E are here, point in the same direction, so it's just cosine of 1, or cosine of 0. So we end up getting E equals lambda L over, we just want the surface area, so it's 2 pi r L epsilon, and those cancel out in the r hat direction. Wait, bro, do we not even have to do anything with that? That's it? That's the whole solution. we define r as just like your distance away from the, distance s. Okay, sorry. It says distance s. And like, if you're a distance s, like this is the magnitude radially outwards, but if you're a distance s, like whatever axis your distance is in is the only component that will be acting on you. Like say we define our coordinate system like this. This is z and this is x. Then if we want to point like here, which is a distance s away, which also is the radius, then our e is going to be e r in the z hat direction. E of s. Oh, this is also vector. See? Easy peasy. But we can just leave it like this. To find the electric field inside and outside a spherical shell of radius r that carries. Okay, well, this is super easy. First of all, back E r is less than r. Okay, so inside is going to be 0, obviously, because Q enclosed is going to be 0, because we have a shell. Do you ever go to tutoring? Yeah, my tutor's right. I have my tutor on right now. My tutor's right here, bro. Like, seriously though. It's like seriously my only tutor. Just the textbook and GPT. But this is because it's like easy classes. Like for my robotics research and stuff, the PhD student that I work with helps me a lot, or like just stuff on the internet. But GPT is a lost cause when it comes to that stuff. Complete lost cause. It's like not even. It's basically useless. It can help you like formulate ideas, I guess, but yeah, GPT sucks. Shout out to the Primogen. What are your thoughts on the direction of AI? Do you think AGI is coming? Well, I think there's no cap on like human innovation and advancement, like just on humanity as a whole. So I guess we're gonna reach AGI at some point, right? Just trivially, like we have to. Like if I believe there's no cap on our advancement as a species, then obviously it has to encapsulate acquiring AGI as well. Is it gonna come from LLMs? I don't know, honestly. You bullish on it in the next 10-ish years? I mean, if you look at the last like 5 years, our scientific advancement, or actually really just like the last 30 years, honestly, has been fairly like exponential. So 10 years, like we're probably going to be advancing pretty quickly. I don't know. It's hard to imagine though, right, that we reach like, and it depends on our definition of AGI first of all. Like, ChatGPT like technically is AGI, like it has general intelligence. It's not a master of all, but if we define like AGI as like a computer that is completely analogous to a human, except it has just like vastly more resources and time, then it might take a while. And we might not even reach it with LLMs, like, because LLMs inherently can't learn without retraining, right? Like a human, I read something, I learn it. They don't learn anything. Like you can throw stuff into your context, like ChatGPT has the memory where they store memory and then they just put it into the context, but the underlying LLM's not actually learning any new information. So until we figure that out, like how to get the underlying model to actually learn and grow as it interacts with data, like and this is like live, like not pre-training. Like at inference, it needs to be able to learn. Then we'll reach AGI, right? When that happens. So I don't know. Hopefully in the next 10 years. I'm excited for AGI personally, but who knows? Yeah, the world in the next 10 years is going to be completely different than it is now. That can sustain 10% annual growth in GDP. What does that even mean? Are you saying if the AI was in power of like the economy, if it was able to sustain 10% growth annually? I guess I don't really get what that means. Like if you're saying if AI ran the economics of our country, it could sustain 10%. Oh, okay. Yeah, well, I mean, that's hard to quantify. Like, how do you quantify AI's impact on the GDP? Yeah, I understand what you're saying now. Yeah, it's interesting. If you had like a really like scientific way, like rigorous way of, or like robust actually is the best word, way of calculating AI's impact on the GDP, then yeah, 10% annual growth is insane. If that's your definition of AGI, then I don't know, that might come pretty soon. I mean, AI can make most decisions and do most jobs if someone knows how to prompt them correctly. Like I could make GPT a software engineer, like a really decent software engineer, if I'm the one prompting it. If I'm the one prompting it and giving it the tools and information that it needs, then I could make a really strong employee out of an AI agent. So I think the capabilities are there, but the use is not. Okay, let's find the electric field inside and outside a spherical shell. Okay, outside, we're gonna have vec E, R is greater than R, is equal to frac. We're gonna have some fraction. We're gonna have Q enclosed over A epsilon naught. Our area is just going to be, what, 4 pi little r squared. The enclosed charge is going to be, so we have some surface charge density. Right, so we're saying surface charge density equals Q enclosed over area, which is 4 pi big R squared. So Q enclosed is going to be sigma 4 pi big R. 4 pi big R squared. And this can obviously be simplified. Oh no. Sorry. I'm supposed to take the pi, not the R. Sigma over epsilon naught. Yeah, sigma R squared over. Yeah, and this can be proven because, like, we know this answer is right. Because at R equals R, at R equals R, we have like E average is gonna equal, like, just like factually, we know that it has to equal sigma over 2 epsilon naught. And we know this is right, obviously, because like we have backslash frac 1/2 times, and let's just put this in parentheses of frac sigma over R squared, right? Oh no, not R squared, for epsilon naught. And then this is just plus 0. Right? So I think that's like our boundary condition from second uniqueness or something. Or no, it's way before second uniqueness. This is from this question. It's like 2.25, I think, actually. Yeah, no. It's this question here, 2.3. 2.30 are consistent with equation 2.33. Yeah, so where's 2.33? See? Sigma over epsilon naught. Wait, where's our sigma over 2 epsilon naught? Isn't the average supposed to be equal to sigma over 2 epsilon naught? Boundary conditions. Yeah, that's fine. Let's just get these problems done. These are really straightforward questions, bro. Suppose the electric field in some region is given by this spherical coordinates for k is a constant. Find the charge density. Okay. Let's find the charge. Okay. No, the magnitude of E. say? Oh, epsilon. I mean, we can solve this in many different ways. Yeah, should we just do the surface integral? Right. The surface integral. They point in the same direction, so it's just gonna be E times integral dA, which is in spherical coordinates. Yeah. So backslash element backslash back E. And then the area is just going to be r squared sine theta d theta d phi. Wait, but there's a problem here because we have different spherical coordinates. Why don't we have any reliance on R? Why you did this your freshman year? Yeah, it's pretty easy stuff. But the class gets way more advanced. It's the first exam in the class. This is like physics 212 kind of stuff. This is the first homework from the class. Which is like physics 2. But this is physics 435. You can look it up. Physics 435 UIUC. This setup is wrong. That was not how you set up this. Yeah, why did I not remember that equation? Wait, what am I doing? What? Oh, because we're in spherical coordinates. Yeah, that's annoying. Let me go. Yeah. Oh, it's so annoying. Okay, so epsilon. What did we say it was? Expressed as frac 1 by. Find the total charge contained within the sphere for each horizontal origin. Should I use Gauss? Should I just use Gauss?
4 pi kr to the 5th epsilon naught. Okay, easy peasy. It's method 1. Let's do method 2. We'll use divided by the volume. Wait, there's 4. No, because we're not gonna get the right. We need 4. Right, because there's a volume for the third. Oh, they integrated. Oh, I guess we can't do that way. Wait, why can't I just do normal volume? Why do I have to? Why do I have to integrate area over? Okay, whatever. What's the E? Oh no, row. We want row. Oh my gosh, so annoying. This is epsilon naught 5k r to the 5th, I think. No, r to the 4th. dr of 4 pi. Wait, yeah, why do I... Homework 1, problem 4.
Why is Mr. Big a mod? Yeah, it actually is because his brain is so big. A while ago, I was stuck on. That was like 2 years ago. What class was that? Probably like Calc 2 or something. I was stuck on Calc 2, and he answered the question. Like, I was working on it for hours, and GPT couldn't even get the answer right. And then Mr. Big sent me the answer, and I put it in my homework, and it was right. And so I made him a mod. Which I guess is actually cheating, so I don't know what the statute of limitations is on cheating on Calc 2 homework in university, so hopefully no one sees this. But I mean, GPT was even getting it wrong. I guess GPT wasn't that good back then, but like it wasn't even close. Like Mr. Big's answer was actually right. I still to this day have no idea how he did it. And I got like 100 in Calc 2. And I still don't know how he did it. Like I was still probably couldn't solve that question. What? I thought density is uniform. Yeah, this is what I was getting, and I was like, why that's wrong? What? No, his Mr. Big, and I don't even care, like, because usually I like to respect other people's like opinions and stuff. Mr. Big quite possibly has the worst political takes ever. Like it's not even close. Not even close. Bro, he's a radical conspiracy theorist fueled by like hatred. Bro literally has the worst opinions. They're grounded in like some truth, and I think he has a lot of intelligence, but his political views are really funny, and that's why people are always arguing with him in the Discord. What did we even do? Oh, no, we integrated the charge density over the area. Wait, no, we didn't. Do you want to go into academia or industry? Neither, honestly. I want to start my well, actually, I am. I'm gonna start my own company. Well, okay, I say that. I mean, I'm probably gonna start my own company unless, like, magically, I join some company early on as like CTO or CEO or something, and I'm really passionate about what they're working on. But other than that, like, I'm gonna start my own thing at some point. Wait, after PhD, what company? You'll be an entrepreneur. Yeah, I'll be an entrepreneur. Yeah, most likely after my PhD. Yeah. I mean, if time, it depends on the climate, right? I mean, well, first of all, I don't know what the company will be. I'm thinking maybe in robotics right now, but I mean, I have years until I actually have to settle on an idea. So the point of the PhD is to gather as much knowledge as possible, so that I'm ready to solve some huge problem and turn it into a company when the time is right. Yeah, that statement I think that you said, Ali, is generally untrue. I'm going to start a company for the sole reason that my utility to humanity is maximized when I control what I'm working on and like what problem I'm solving, right? And to do that, you have to be like high up in a company. You have to be the person that's leading the direction and like passion or the problem that the company is solving, right? That's the reason that I'm going to start a company. I don't need an idea right now, actually. And I think it's actually better to not have an idea right now, because I'm waiting for an idea that is like actually like truly monumental to humanity, right? And to even find ideas like that requires a crazy amount of like knowledge and expertise, as you say. And so that's why I'm pursuing a PhD. Is like when I go to my PhD, I'm gonna be deep diving into AI and robotics and all these other topics, and hopefully along that journey I find something really powerful, either a solution to some problem or a problem and just the problem without a solution. And then I'll start a company in order to pursue that like with full effort, solving that problem or commercializing my solution to a problem. So I think you can just say I want to start a company. I think it's entirely valid. So I guess, I mean, in a sense, I do have a strong reason, and my goal is to attain the expertise needed. Or honestly, I don't even need to attain the expertise before I go and like go out on the venture, because usually you solve the problem as you go. But there's the issue, like you don't want to get into like a Theranos situation where you jump at some huge problem and you just don't have the knowledge to solve the problem. Then you like go to jail for misleading investors and fraud. Is there a way you deal with the lack of discipline? Not really. I just kind of do things. Just wake up and do it. It's like it doesn't get done by itself, so. I mean, like I think at the end of the day, it just comes down to like, what are my goals? Like my immediate goals are to like, well, actually, overall, like in my life, I value like just trying hard at everything that I do, like putting my best foot forward and actually like putting all my effort into what I'm doing. So right now, what I'm doing is school, and to put in all my effort, you know, I have to get up and do my work. I have to study for my exams. Right. And also, like, my immediate goal is to go to grad school. And so I'm gonna have to get good grades to go to grad school. And to get good grades, I have to study. So it's like not even like discipline at that point. It's just like, okay, like this is what I have to do. So I just wake up and do it. Like, I have to. It's not really discipline, honestly. Like, I just have no other choice. Right? Crazy I've solved these exercises. Good for you, bro. It is crazy. It's gonna be so crazy. In like 20 years, I'm gonna look at these stupid homework assignments that I'm doing and I'm gonna be like, wow, I could solve that in my prime. You know? It's gonna be crazy. Do you have a part-time job? I have 2 part-time jobs right now. Yeah. And there's all this information is also like readily available on my website. So, I mean, it depends on what you call a job, right? I mean, I'm doing research with a bunch of different like research groups and professors and labs. But I do get paid for one of like well, I guess it's not even research anymore. I'm more of a software engineer now, so that's one of my part-time jobs. And then I'm also working on a company that a professor that I was doing research with has started, and he hired me to work for his company. And so I build software and do AI engineering there as well. Does genetics really affect how you study at university? I think genetics affects like overall everything about your life, right? I mean, genetics affects your body, and your body affects everything that you do when you're living. So of course it does. But whether that's negative or positive, I guess, is up to you and how you utilize like what you've been given. Like, I could say I'm a slow learner, and that is like a bad thing. Or, I mean, it could also be a good thing. It just like depends. Like, I feel like you could spin it off into being a good thing. Like, oh, I'm a slow learner, so I have to try way harder than my classmates to learn like the same amount of information. And so you build like real valuable skills doing that. Like, you build work ethic, discipline, dedication. And so that actually in the long term is going to be more beneficial for you than just being like a genius out of the gate, right? So genetics affects you, but I mean, how it affects you is up to you and like what you do on a day-to-day basis. How would you recommend an undergrad and comp sci go about finding research roles? The first ever research role I got was freshman year, I think, and or sophomore. I don't remember, but I just emailed professors. I sent out like 20 emails. Only one got back to me and said he wasn't taking undergrads, and then like 4 months later, like literally 4 months later, after I'd sent the initial 20 emails, I had thought I was looking at other research opportunities. I was trying to apply for these different things, but a professor reached back out to me and responded, which is Vikram, who I currently work with, and it ended up being like one of the best experiences of my life. I've learned a lot with him and done a lot of valuable research, and now that's the professor who's starting a company, and I'm working at his company. So there's a bunch of ways to find research opportunities. Say just apply. NSF has a bunch. You can reach out to your college advisors. They're going to give you a bunch of resources for it. And then just cold emailing professors. That's what I jumped to initially, was just cold emailing professors. And I think it's the best, because working with a professor is like an experience that is way better than working with some like research institute, in my opinion. I mean, it depends. I think on average, though, working with a professor is better, especially like established or distinguished professors who were researching in fields you were interested in. Yeah, absolutely. I mean, I wasn't emailing like biology professors. I was emailing professors who were researching AI. My school has like a directory where you can see the research interests of professors. So if you don't have that, then it's a little bit more tedious. Just look at professors who are teaching AI courses, or ask your advisor, of course, or an advisor in that department, because they're going to know these people by name. But yeah, there's plenty of things you can do. Yeah, I didn't really shock on it. The 20 professors, I think that's a hyperbole as well. I don't think it was actually 20. I think it was less. But the professors were highly aligned with my research interests. So I did not, I mean, because that's just going to be a bad experience, researching stuff that you don't want to do. Like, that's terrible. Literally couldn't imagine something worse. Yeah, and that just is kind of luck, whether your school has AI professors and if they're good or not. So, yeah, you're gaming. That's fire, bro. Bro, why is ChatGPT patronizing me, bro? Yeah, this one. Volume integral of density. Sine theta dr d theta d phi. Derivative over angles. Gives 4 pi r squared. Oh, because it's sine theta. Wait, what? Oh, 1 plus 1, yeah, that's right. Oh, yeah. Okay, yeah, I should write that out then. Like, there's just this integral kind of like comes out of nowhere, right? So. Yeah, rho d tau, yeah, exactly. Right. Let's do 2 pi on the outside, actually.
What is I? What about I? Where am I? What about an I? Backslash in pi? Oh, this. Okay, 0 to 2 pi, 0 to pi. Oh, and then 0 to r. dr d theta d phi r squared sine squared r to the fourth. Oh no, we'll do that after. Wait, no, we won't do that after. We'll do that now. Let me just put it here actually. Right, so these two integrals yield 4 pi, and then we already have this r squared in here. Yeah, this is misleading. Let me actually not even write it like that. Because it's not 4 pi r squared. It ends up being 4 pi r squared after you evaluate it, but like it just looked like I had just some random area just thrown in there for some reason. Now this is like really explicit. Like these two integrals clearly turn into 4 pi. We pull out the 5k epsilon naught from the integral. And then everything else is the same. And then we obviously evaluate this. And we have a big R, bro. There's all sorts of mistakes in this document. Yeah, these are both big R. This is big R too. Like, whoa, did I not do Gauss's law? This is big R. And this is rho at big R. Or E at big R. Okay, I need to go to the bathroom. Oops.
noise from the robot is annoying. Oh, from ChatGPT, yeah. ChatGPT is so annoying sometimes. Linus is very disappointed now that you're using Macs. I still use Linux, bro. I still use Linux, bro. Look. Look. See? Arch Linux, bro. What are you talking about? What are you talking about, bro? I use Linux. Should we check on my training, actually? Oh, crap. Now I gotta do this. Where am I trying to go? Yeah. I stopped clicking random buttons, man. It was successful? Yes, let's go. Look. Data generation. Bro, it took 11 hours. Look. What's the time? 12 hours, 6 minutes, and 20 seconds. Where did it save to? Data. There's all the data, bro. So I just need to do some fine tuning now. Whatever. It's fine. We'll do it later. Yeah, don't diss me, bro. Don't diss me, bro. I use Linux. What? Is this Mac Linux hybrid? No, I use Tailscaled. I don't think that'll leak. I don't think that leaks anything, actually, but it shouldn't, right? Oh. Well. Well, I use Tailscaled, so whatever. Bro, no way, bro. Oh, can this thing get out of my way? Oh, let's go. Let's go, bro. I'm a goat. Well, I'm lucky. I was gonna say if you could, no one saw it anyways, I don't think. I don't think you can get it. Yeah, you can't see it. Okay, because I leaked my IP address. My public IP address too. But no one saw it. You can't see it on stream. I was gonna say, like, did anyone see it? But I mean, I don't want to tell anybody that, like, oh, go look at my IP address, by the way. But my webcam covered it. LFG. You major in physics or engineering? My school of physics is engineering. So, like, I have to major in my physics degree. I can actually just show you. So, right, Granger College of Engineering, Physics. Can we see, like, degree requirements or something? Lost it. Okay, let's,
Let me show you. Sorry, this is taking a while. Okay. So for engineering physics, like to graduate, we have to pick a program track. So you choose like any engineering discipline. So they have like computer science, they have nuclear, graduate study class. But what most kids do is they make their own track. So like if we go to my degree audit, we can see, which I actually am gonna have to make sure this is actually important information, so we gotta make sure I don't leak anything. But I'll pull up my degree audit to show you. No, that's the wrong thing. Okay, this shouldn't leak anything. So we have here technical option, student planned. So 6 of my courses, or 1, 2, 3, 4, 4 of my courses that count towards my graduation are in like some applied engineering discipline that I choose. And so mine is artificial intelligence and like kind of robotics. So CS 441 is Intro to Artificial Intelligence. CS 444 is Deep Learning for Computer Vision. CS 446 is Machine Learning. I'm in that currently. And ECE 398 is Robotics Project. And so these classes are part of like my core degree. And they're just any engineering discipline. So I know people who do like mechanical engineering, civil engineering. I know someone who's doing like religion. It's very interesting. But it's very flexible. Like so, you can major in physics and then also do any engineering discipline that you wanted to. But like I'm almost done. I'm almost ready to graduate. Like I only need one course here. I need one course here. And that's it. That's it. I guess I need one course here. Yeah, it needs 3 hours for my minor. So I need 3 more I have 3 more courses till I can graduate. Yeah. I need 3 courses in total till I graduate. But as we see by my degree plan, like I'm barely gonna be able to graduate. Wait, why do I only need 3 more courses? Shouldn't I need 4 more? My degree? 1, 2, 3, 4. Wait, hold on. I'm missing a class. Oh, this is old, right? Yeah, this is old because, yeah, I dropped EC 404. I dropped EC 404. I might re-add it, which is actually like a process. But I dropped it. So I need actually 4 more courses to graduate. Yeah, I'm quite embarrassed about that actually. Okay, so I haven't done work in like so long. What were we doing? Problem 3. Find the electric field at distance Z above the center of a flat circular disk of radius R that carries a uniform surface charge. Which is a formula. Okay, this is easy. So let's just do Gauss's law. Why not? And I'm not even gonna write it out. So fraction. What's our surface charge density? What is density? It's like Q over area? Yeah, so it's backslash sigma times area, which is pi r squared, big R squared, divided by, so we have epsilon naught for sure. And then we have the area of our Gaussian surface. We low-key don't even need to use the area of our Gaussian surface. Wait, why are we doing Gauss's law? We can't really do Gauss's law here, actually. Right? Can you? Enclosing... Oh, I guess you could. You could do a cylinder. But it's not necessary. Like, this is just script R. Yeah. Wait, but this is not right for some reason. Find the electric field difference Z. So we are only concerned with the Z direction. The electric field. So we can make this a fraction or a thing, a vector. Yeah, this is Q, so this is definitely actually Q. Oh, but we're not using Gauss's law, are we? Yeah, no, we're not. Wait, I think this is just the answer. Wait, no, it's not. Wait, yeah, it is, right? In the event R goes to infinity, then we should have that of a plane. Wait, so this answer is wrong. So why would we get 0? Doesn't make any sense. But this is just like, the problem is this is so early in the text that like I don't even remember like what was going on back in these days. Oh right, you just use these equations. Yeah, simple enough. Okay, so it's R squared. Okay, sorry. Yeah, let me use that equation. So you have vec E equals frac 1 over 4 pi. Like I was trying to use Gauss's law, but you can't use Gauss's law here. What do we have? We have a surface charge density. This is me rho over R squared. Or sigma. And like for, like just to be rigorous, but what we notice is this is C dot. This is a vector A, right? Oh no, it's not a dot product. But no one really cares about this. We can just pull it out. And it's actually in the Z hat direction. That's not what we're concerned with. And dA in this case is just going to be r dr d theta. Which is d theta doesn't actually matter. It's just 2 pi. 2 pi sigma r squared. Oh, that makes it even easier actually. R squared, so we just get little r squared plus z squared. Why is that r squared? Super easy integral. So let's change our bounds. It's like backslash big. You know, like this. Why do we need two of them? Can we just do one? Yeah. Okay. And we're gonna have just gonna be z squared. This is natural log, right? Actually. Yeah, we're gonna have a 1/2, so this 2 goes away. This is just ln. Wait, I don't recall having ln, bro. This has gotta be wrong. This should just be like super straightforward. It's cubed. Yeah, why is it cubed? Wait, what? Yeah, let me do, okay. So the problem is like, this builds off of this. So let's just do problem 1 first. Let's do the other way around. Let's do problem 1 first, so. Charge for the E field of a point charge is 1. This is gonna be in the z direction. Just do script R for now. Wait, yeah, why do we need a new line here? Some. No, we don't need either of those actually. It's just some over I. Excuse me. Never mind, physics 435. Yeah, that's right. Okay, so they changed up we can obviously factor this out. We're gonna have left, right. Frac plus Q at a distance SQRT. Okay, this is the naive thought or approach. Right, this is what we're supposed to think is the answer, but it's not, because we have charge minus q at a distance minus d over 2. And the minus z hat direction. Wait, hold on. Oh, that's because yes. Okay. If we have a minus charge, then the x direction is what accumulates. Like, could we draw this out? Like, we have this. So it's like, say this is minus q, right? Yeah. This is minus d over 2. So we're going to have this going this way, and this going like that. And these are the electric fields, or electric field lines. So this is obviously going this direction, this going this direction. So this z cancels out, obviously, but then we have in the x direction, they're both going the same distance, the same direction. So we have this theta here, and we know that cosine of theta is equal to, let's just denote these both as r. We have, no, it's d by 2. Wait, no, z, sorry. Z by r. Adjacent over hypotenuse. Wait, but we're concerned with the x direction? So we'd actually be using sine of that theta, right? Like, we want this angle here. Where z component 0. Plus or minus d by 2. So let's actually write, so in general, the E field by both of these is this. So in general, the E field is this. So we have plus minus this, and we have plus minus this. This doesn't matter, this plus minus, but it's fine. And so if we want just the x component, then we take it's actually not theta from this image, but it's fine. It's just phi. So let's take this, where here, this is going to be times, let's set what we say cosine theta equals frac So these minus signs cancel out. And we get script R cubed. Crap. Let's write that. Script R cubed. Script R cubed. And let's get rid of these. To get rid of both of them, actually, just completely. Right? Yeah. Exactly. And we can put, no, not there. Here. Nice. Yeah, this picture's wrong. That's why I said that initially, but this picture's wrong. We don't want to use this theta. We want to use the theta down here, and then also this is minus q, so e should be pointing the other direction. Okay, next question. This one should be easy. So find the electric field density above the center of the circle loop. Here, radius r. Okay, from line charge. Okay, so we gotta integrate lambda. We have our distance vector. What do we want? Y z squared plus r squared. That's gonna be r. No. Yeah, see, this is wrong. Hold on. We want to take an infinitesimally small length, which I guess could be dr actually, but then we would need a theta as well. I want to do dl, but I actually don't think that that's possible. Dude, my acai bowl is still not eaten. But I integrate over this whole time. Actually, R is constant. R is constant, so we can't integrate with respect to R. We can, however, integrate with respect to theta. Yeah, but I feel like this is wrong. Because what's the length of the... Dude, am I rebooted, bro? Yeah. We're only using the angle between P and Z as cosine. Yeah, that's like kind of what I did. What kind of what I was gonna do. Okay. This is straight from the textbook. And this is in the R hat. Okay, well, I guess we're back. Huh. Do we have Wi-Fi? Okay. I guess we're back then? Hello? Oh, now there's a huge delay though. Wait, my Wi-Fi is being garbage. Wait, now my Wi-Fi is terrible. Okay, wait, hold on, let me do speed test. Yo, I gotta change Wi-Fi. Hold on. Wait, that's actually nuts. Okay, I'm about to change Wi-Fi's. Alright, we're gonna... It says connected, excellent quality. Oh, there we go. Yeah, that was cooked, bro. That was cooked, bro. That Wi-Fi is unjoinable. So where do we leave off? Oh, we're doing this simple integral. A super simple integral. We're gonna pull this lambda out here. And we're gonna, let's just keep that by itself because
Oh, sorry. We need cosine. Cosine theta. And this is squared for some reason. And our cosine theta is going to equal, take theta to be the angle between P or Z and height of the hypotenuse. We're going to have frac Z by script R, which means right arrow, vac E is equal to frac lambda option key wasn't working. Okay. This denominator is pi epsilon naught script R cubed. We have a Z in the numerator. And this is in the Z hat. Z lambda over 4 pi epsilon naught cubed. Where are we saying this R comes from? Oh, I didn't evaluate the integral. I never evaluated the integral. That's what I was missing. Okay, so that's 2 pi R. 2 pi R. I never evaluated the integral, so that just carries all the way through. So 2 epsilon naught ZR is RZ lambda. RZ lambda over 2 epsilon naught R cubed in the Z hat direction. So this implies that our Q enclosed equals fraction right to fraction. It's gonna be Q. Yeah, it's supposed to be Q over epsilon naught. So this whole thing, RZ lambda divided by 2 script R cubed. Okay. So for this question then, there's a couple ways to do it. The way that I typically do it though is I take rings and I integrate over the radius. Because we know the electric field from each ring. Right. And lambda is charge per unit length. And what do we want? Sigma? Sigma is charge per unit area. And dA, of course. Well, actually, equals sigma times dA by dL. Which is just area per unit length. Isn't it supposed to be like dr? Isn't it supposed to be dr, bro? Yeah, see, this is what I wrote. And then Q equals 2 pi r lambda. Oh, right. Wait, hold on. Q does not equal this. Q equals lambda times, what is it, 2 pi r. Yeah. What does this have to do with anything? Wait, what? Lambda equals Q, or Q equals 2 pi, or lambda, Z equals ZQ. This is the field from a ring. And why not instead just use the equation that we were given? This one? Yeah, that's stupid. What a stupid explanation I'm using. Yeah, why am I, that's like the worst way to solve this problem. The best way to solve this problem is to just use the equation that we have. Vec E equals 1 by 4 pi epsilon naught. Int sigma over script r squared, and the r hat r script r. In this script r direction with respect to, should be dA though, right? Yeah, dA. Okay. And then this is obviously, we know again that the x component cancels out, so we're only interested in the z component. Right, so again we have cosine by theta equals so if we're only interested in the z component, then we have to relate z to r, so we do frac z by r by script r. Right? And that gives us the E in the z direction. Cos theta. And let's go ahead and give us the area. Well, actually, I think we only need to integrate over r. Yeah, we just need to integrate over r. Why not theta though?
is supposed to be RD theta, right? DA is supposed to be RD theta. Second year E&M, yeah, this is second year E&M. Yeah, RD theta, exactly. Okay, so I was right. Okay. RD theta. But we know a bunch of things. Right. We know that cosine, so we're gonna substitute cosine theta then. Let's just grab this whole thing. So we know cosine theta is z by r squared. So it's gonna give us z sigma. In the numerator, and then let's erase this r here. And d theta is just going to turn into 2 pi. RDR, yeah. This is from 0 to big R. Hello? Oh, okay, good. Okay, so we have use substitution. Squared plus z squared to the 3 by 2. And this is going to be integrated from 0 to r. So we have u equals r squared plus z squared. 1/2 du equals r dr. So we factor out a 2, so we're just left with a pi here. Or factor out of 1/2, actually. So we're left with u to the minus 3 by 2. Well, almost made a big mistake there. And then we change our bounds to be z squared and r squared plus z squared. So we get r to the minus 1 by 2. Okay, so we add another 2 back. 2 back here. From our integration. Why do I have a minus sign though? In my thing. In any case, we get 1 over r squared plus z squared minus 1 by z squared. Okay, that's how we can get rid of the minus sign, actually. We'll do 1 by z squared minus 1 by r squared plus z squared. Okay, perfect. Just for simplicity, we can just do this. Left. Frac 1 by z. No, just 1 by z, sorry. Frac 1 by r squared plus z squared. And we can put the z back in if we want. So we're just going to 1. And then everything should cancel, but we don't need to cancel it. Sigma over 2 epsilon naught 1 minus z over and the z hat. Nice. Let's check with the actual answer key. Which question is this? Is this question? No. Here. No. Here. Here. Oh. You're right. That is actually plus or minus 1. Oh, so we actually can't simplify that like that. This is a 1. Yeah, we have to keep the z. Okay, fine, we can have z. But this is a fraction. This isn't actually a 1. Because we have z squared. Z squared, no, root z squared. Wait, no. We have z squared square root, sorry. So z squared, like this, the square root of z squared is absolute value of z. Which z by z is 1. Oh no, this is always positive actually. It's always 1. Wait, what is this answer key talking about? This is always 1. There's no reason to distinguish that we have z by root z. Oh no, it's not always 1, sorry. If z is negative, then it's minus 1. Yeah, so we'll just leave our answer like this. But why do they have to write their answers like this? So we have 2 pi sigma z outside of 1 by absolute z, 1 by root z squared r squared. And we have 1 by 4 pi epsilon naught outside all of that. Yeah. And the z hat. Yeah, our answers are equivalent. I don't know why they had to do that stupid simplification. Let me add some simplification. Yeah, nice. Okay, so all of our answers should be correct. ZR lambda, bro, knowing them, they're gonna have some stupid answer. Yeah, bro, like, come on, do you not know how to simplify? Oh my gosh. Okay, so we have r cubed, right? We have epsilon naught, and theirs is lambda ZR over 2. Lambda ZR over 2. This is why I hate these answer keys, bro. Like, bro, what is this, bro? Just write it simply like how I have it. QD over 4 pi epsilon naught r cubed. Yeah, in the x hat direction. Correct. Okay, we're done. We just redone all the homeworks for the second time. I already did them yesterday and made this answer key. But my answers are actually not like right. Like, this answer is not. Like, it's right, but like this is not a correct way of thinking about it. It's so easy. Look how easy I did it, and look how hard I did it the first time. It's like idiotic. Like, just integrate. This is the easiest intro I've ever done in my life. But I did all this nonsense. Look, like we're just pulling stuff out of nowhere. That's stupid. Bro is back. Indeed. Second year E&M, indeed. Do you think computer engineering is a waste of time? I'm 25 years old and want to go back to school and deciding an engineering major. Of course computer engineering is not a waste of time. Yeah, of course not. It's foolish. Okay, I'm gonna put this. I've had this sandwich sitting here, but I'm not gonna eat it, so I'm just gonna put it in the fridge. Alrighty. Yeah, 25 is still young. Go for it. Absolutely. What is yes? What are you talking about, yes? Bro is live. Yes, I'm live. I'm confused. Taking classical mechanics next semester. Any tips? No. I mean, I don't have any tips. Just study, I guess. Go to lecture. Read the textbook. Go to lecture. Read the textbook. Study. Those are my tips. Sorry, I can't be more helpful, but I don't really know what else to say. Okay, I need a 8 by 11 sheet of paper. Three problems, no electronics. You have access to a provided formula sheet and one sheet, both sides that you can write yourself. Oh, I guess it could be any size of paper then. Wait, they're not providing any more information. Should I print? You think I can print? Wait, you think I can print it, bro? They're not saying I can't. Wait, I also have a question. Like, is the exam tomorrow during lecture, or is exam during discussion? Whatever. I don't know. You have an exam tomorrow for machine learning? I have an exam soon in machine learning. Okay, so I need to do something. I need to study something. I think I'm gonna study, can GPT turn this into LaTeX? GPT-5 is still ass. Yeah, GPT-5 is pretty trash. There's only 3 questions on the exam. What? Bro, is it serious? Is it being dead ass, bro? Did you guys see that answer? Like, is it serious? It's because you need to do thinking. But for some reason, like, standard GPT doesn't actually look into the documents. Like, if you don't put thinking on, like we just saw, it never actually looked at the document. Right, watch. If I do thinking, then it actually, look, it actually like looks at the document. Like, cause the difference is like, when they do just like upload PDF and it doesn't actually look at it, it doesn't take screenshots of each page and then upload that to like a transform model for to understand what's going on. Instead, it uses like the OCR to get all the text, and then it like does RAG, which is so useless, especially for handwritten stuff. Like OCR is so bad for handwritten. That's stupid. How naive can you be, bro? Do you have any idea what you want to do after you graduate? Yeah, I kind of talked about that earlier. Low-key not doing the whole spiel again. Google AI Studio is better with files. Yeah, that's true. Yeah, I can look at the file like a human, basically. Yeah, so can GPT, but it can only, like, as what I was saying, it can only do it in the thinking mode. In normal mode, it doesn't actually do it. It just, like, looks at it like a robot does, which is so dumb. Because, like, if I uploaded each one of these as an image to GPT, it would be able to look at it like a human. Like, I mean, you could ask it questions about, like, what is this, bro? Why is it... I'm gonna download the text file, bro. Just give me the content, bro. Okay, let's see what it says. Let's see if this is right. Okay, let's see if GPT is right. Let's check GPT's ability to... 3 problems, no electronics. You will be provided a formula sheet. You may bring one, both sides that you write yourself. Contributions to the electric field and the force. Yeah, it missed these two equations here. But I guess we can rate them ourselves. Or actually, did it miss them? Yeah, it did, right? Preposition. Can I just put a vector out here? Or do I need to wrap it? Yeah, I need to wrap it. Right? Yeah. Let me double. Okay, let me get cursor back on. Because he'll know exactly what I'm trying to say, bro. Tired of writing all this John out, all this stuff out. Nope, that's not right. 1. Yes. Kind of. This is wrong. Instead we want backslash int. What's going on? What's the error? Okay, int. That is frac. Yeah, that's right. Except we're gonna do row. What's the problem here? Script R? Oh yeah. Let me take any more packages. Where do I define script R? Here. Yes. You know what? Let me just add this as a subsection. Big skip. Fudge. sequence? Oh, yeah, because we're using sections. That's annoying. Okay, it's fine. We can just do like this. And then we'll use subsections for everything else. Yes, here you go. Okay, new chapter. Sure, do whatever you want for the day, I don't care. Exam format. Put that here. We don't need this anymore. These are all going to be subsections. They're all going to be subsections. And apparently I still have some error. Undefined control sequence. \VB. Okay, so that needs to be defined. What's it using \VB for? \V c dot. So make it a vector? That's annoying. Why do they do that? Yeah. All the \V's should be replaced with back. Oh, it's so annoying. No, see, we don't want that one. It's fine. We'll fix it after. What is going on? What did I just do, actually? \VA R epsilon naught. What is VAR epsilon naught, bro? Okay, now we only have one error left. What is it saying? Undefined control sequence, recently read /curl. Oh, I want /curl. Wait, curl, there's no need to do that though. Spec BE. Yo, why don't you just use \cross? Oh yeah, times. Right? Electrostatic potential, What is this 0? Oh, this is bad, bro. Look at the formatting. This is so trash. Ah, hell no. Get this shit out of here, bro. Get this yawn out of here, bro. Get this yawn out of here, bro. Bro, GBT is the worst at LaTeX, bro. I mean, there's really no reason to even add this to my thing. What do you have about it? But I guess we should add it. It's fine. We don't need any new packages. Physics, geometry. No, we don't need any. Oops, did I paste it? Yeah, I did. Did you do a REU over the summer? It is research. Oh wait, what did REU stand for? Research undergraduate? What did REU stand for? Oh, research experience undergrad. I had a research experience and I am an undergrad. So is that how that works, or is REU like some sort of program? But in any case, yeah, I think it is actually an REU as well. So yeah. NSF funded? I don't know if we were NSF funded. We might have been. We're funded by something though. Yeah, I guess it would be an REU. What time is it there? It's 15:58. 3:58. Yo, what was that Arch Linux in your Mac? LOL, that looked weird. He's moving to Silicon Valley chat and work at the big tech companies. Never that, bro. Ollie Guliev, probably just a headless arch using SSH or something. That is exactly what it is. That is like literally exactly what it is. It's just an arch install with no GUI, and then I SSH into it. Talk about bloatware, bro. I have nothing. I don't even have GNOME. My computer came with Pac-Man. Or not computer, but like OS. It came with Pac-Man, that's it. I didn't install like everything, even like CMake or build tools or anything. Oh, that is cool. Like self-hosting? Yeah, it is like self-hosting. It's my own AI server. It's under my desk right now, actually. That looked like a virtual machine, but I don't know what is the difference. I mean, I guess you could classify that as a virtual. It is a virtual machine. In a virtual machine, yeah, it is a virtual machine technically. So yeah, it is the same. Or are you coding notes? Unfortunately, yes. Well, right now the AI is coding my notes, but yeah. What time is it there? I already answered that. How can you study for so long without a break? I can never longer than 2 hours. Taking plenty of breaks, bro. I just took a break now, just talking to chat. It's definitely a break. Definitely counts as a break, bro. Bro, what are these? What is section star, bro? We should not have section star. We don't even use section star here, bro. I use subsection. I do use section, though. Overall section. So let's place all section stars. Subsection. That looks way this looks fine for the most part. Okay, let's copy over anything that was missed. Shoot, how do I? What's it? What is the best way to do this? Here, like this, and then I'm gonna close chat. Take up so much space. Okay, so that's how we'll do this. Oh, this actually shouldn't even be in this document. This should be in my lecture notes doc, because my lecture notes is way more comprehensive. Server is in a separate computer, yeah. But VMs can be on your computer or on separate computers. Like you'd call an EC2 instance like a VM. And then you're SSHing into the VM. VM typically just means like, but I guess mine's not a VM because mine, no, it is still containerized. So yeah, I guess it's a VM. Like what's the dictionary definition of a virtual machine? Software-based digital version of a physical computer running on its own operating system and applications independent on a single physical host machine. Okay, so so it's not a VM. Yeah, it's not a VM. Because my PC, actually my PC does have multiple operating systems, but they're not on the same, drive, so they're completely separate. And I actually wiped my other OS, so actually I only have one OS. Yeah. So it's not technically a VM, right? Digital version of a physical computer running its own operating system and applications independently on a single physical host machine. Yeah, no. Yeah. Yeah, serverless is no, serverless? What is serverless? Oh no, you didn't say serverless. Oh. And what are the benefits of this? Why do you need Arch SSH instance in your Mac? Okay, I think if I just explain to you like my setup, it will, all your questions may go away. So, I have. Wait, should I? I could actually show. Okay, whatever. But listen, I have my current PC Okay, wait, listen. Let me restart. I have my MacBook that I'm on right now, that I do all my work on, stream, whatever. And then I have my PC, which is like my AI server. It has a 4090. I'm installing a 5090 into it right now. And it has like Ryzen 9, like it's really spec'd out. Terabytes and terabytes of storage, tons of RAM. So it can handle like any workloads that I have, like AI workloads. A lot of the research I do, I have to use it. But it only has an Arch operating system and it has no GUI. So it takes up no RAM, well basically no RAM, no CPU, no NVMe, like no storage to run my PC. Like my PC uses no compute at all. But the thing about that is like it's terrible to use. Like if I switched my HDMI input to be my PC, all I'd have is a command line, and the command line looks like crap. Even though I do have Zish installed. So what I do is I'm on my Mac and then I SSH into my PC from my Mac. Like if we, oh well actually that would leak my IP address. I was gonna show you guys the command that runs, but it will leak my IP, so let me. Okay, whatever. So I have this command, AI serve, which is basically an alias for like SSH my PC, right? And so I can SSH into my PC. Oh, I guess I leak my IP address anyways. And then I'm able to use like my compute. Right? Like I have a 4090. See. able to use my computer. But I can do that from anywhere in the world because I have Tailscale, which Tailscale just like provides a VPN service that allows you like hop around routers, because routers have a bunch. So when you put up a SSH server, it typically only works for like your home network. So I turn on my SSH server, and it tells your router to start amplifying some port, like port 22, that allows anyone on that Wi-Fi to connect to port 22 and SSH into your computer. Obviously, there's like a password and stuff. But what Tailscale does is it basically like goes around your router and instead creates a VPN that you can connect to on any public internet. And so when I send an SSH request, it goes to Tailscale. Tailscale sends it to my router and then sends it to my PC. And now my Mac and my PC are connected from anywhere in the world. And I don't need to be on the same Wi-Fi connection as it. What is it? What are you saying? What is on the screen right now? I see stuff on the side and some tabs. What is this? What tabs? Like on the left? These tabs on the left? These are just files. That is an insane setup. Yeah, it's a really good setup. Like I have this beast mode Mac that can handle like running a billion apps all at the same time, right? And then, wait, where's my performance? I should have like, I guess I got rid of it. But, and it lasts forever, like battery. I can do a lot on my Mac. And then when I need a compute heavy workflow, like anything that's compute heavy, I literally just run this one command, and now I have access to all the compute I could ever dream of. And I can like train AI models from my Mac. And an even cooler feature is that on Cursor, I can actually connect to my SSH, right? So I can connect to my server, and now I have a Cursor window, or we could do this in VS Code, or if I open Vim in the terminal, and I can interact with my computer and start like training things. So like, I'll just show you guys what I'm working on in my some of my research. Let's just open this entire thing. Okay, so I need more. I keep running. This is like my 8th time running this command, bro. This is even more of a like crazy setup, but env Isaac Lab, right? And so I should be able to run Isaac Sim. Okay, wait, but I need it to be headless. Control C. I need it to be headless. So this is a problem that I have that, oh my gosh, bro. Hold on, let me. It's a problem that I have because my computer doesn't have a GUI. So like things like Isaac Sim, which require a GUI, I have to run them using like these kind of unconventional ways. Wait, what is it? What's the command? It's not .headless, bro. Wait, what is the command that I'm supposed to be running? Yeah, this command. Yeah, here we go. Okay. So when I run that, and then I can go on WebRTC. Okay, this one I actually can't leak. This IP address, I actually can't leak because this is my one. Do I know it off the top of my head though? I think it's this and this.
What's my IP address, bro? I have it in my notes. That's annoying. Okay, here we go. Oh, that's why. I was mixing up my public IP and my. Okay, and so now I can run like Isaac Sim, which requires like tons of compute. Like I can hear my GPU running right now. Let's do well, I guess we're not running a lot of compute right now, but like if I loaded in like my schematics or my setup, like let's load in one of my robots. This is the robot that I'm actually doing research with right now. Here. We want G1, 29 degrees of freedom. Oh wait, let me let's do flat grid. And so we throw in this robot, and now we have a simulation like where I can, interact with this robot. And there's physics and stuff, like I play it, like you see the physics happening. I can move the robot around, like if I grab one of these joints, and let's select the entire robot. Like I can move the knee or something, and if I play the physics now, the robot's obviously gonna fall over it. And so what you can do is I can connect like a policy. I can connect a policy into this that controls like these joint movements, and then I can train it in Isaac Lab, right? But this is not possible on like a Mac. Like it's just not. You have to have a GPU, and you actually have to have like a RTX GPU and a new RTX. And so I'm able to like run stuff like that on my Mac without needing to like actually boot up my PC or anything, and I can do this anywhere in the world. Like I don't need to be next to my PC or anything. And so that's like the main use case of it. And then I have all my code here. Like this is what we were just looking at. Well, actually this is like when I was training the model. This is on like the gripper. So if I go to the videos, this is with the gripper 3 for picking up apples and stuff with the Unitree G1. But I trained that model actually on like, right here on my Mac, but like it's SSH'd into my PC, and I can run inference on that model, which I guess I'll just do that. No, we want to be in a different. Bro, this thing knows me so well, bro. What happened? Yeah, whatever. CD, Isaac, root. No, not that command, bro. Hold on, wait, what is the file that I want to run, actually? It's scripts, inference, G1. Yes, exactly. Oh, I need to start the server up though. Okay, well this is actually kind of more annoying. Oh my gosh, okay, fine. For the sake of just taking a break from studying, I'll show you. I'll actually do this. And then accept not client. This is going to be the server. And we don't even care what port it runs on. We got to make sure it runs on 555 though.
So this is loading my model that I trained. It has the pre-trained version, but then I fine-tuned it. Okay, we don't need the new embodiment tag. Okay, wait, hold on. Let me just get the... so annoying. Do I even need... So I don't need the embodiment tag. Oh, because I need to specify the model path. Bro, I don't remember. I don't remember my model path, bro. Why am I doing this? Okay, it's fine. I have it in some chat here. No, none of these. Yes. Perfect. What is going on? What is going on here, bro? Bro, where did my... I just control C'd it, bro. Where did it go? Okay, like what is going on? Is it not gonna copy this? Copy. Paste. Fudge. Well, why is it doing that? Just manually erase it, bro. Okay, there we go. And so this should load my, yeah, see, Aidan checkpoints, Unitary G1 fine tune. And it should be on port 555. And now we can run this command. And it should give us an array. Yes, see? So here's our prediction from the GRU N1 model. Well, these are really just like the, whatever, but we have the actions and we have the action space. This is what I'm asking it to do. It's just an arbitrary command, but we're getting a prediction from GRU. But can I get out of this? Because I don't need this anymore. Let's kill both these terminals. Let's Control C. Nice. Get out of here. Okay. We need to do a couple things. I need to do my physics. I do have physics homework due tomorrow, which I probably should start at least today. At least start it today. Homework 4, what's today? Homework 5? The 6th is tomorrow, yeah. Oh my gosh. It's total drag. What is this? Oh yeah, right, I know what that is actually. Hello, Acrobat. Any day now. This is how I do all my homework assignments, bro. How many questions are there? 5. Hello? Hello, why can't I add a page? What? Am I not in edit? Wait, what is going on? Why can't I edit the pages? What's going on over here? It's asking me to sign in.
my phone? Still plugged in from last night. I haven't gone on it yet today. But I need my login for Adobe. Bro, why do we do this, bro? Why do we have these crazy passwords? Bro, what is that? 6, 7, 1, 2, 3, 4. Bro, that has to be the craziest password I've ever seen in my entire life. Apparently it's wrong, though. Wait, it says this password's wrong. Oh, it's probably I think it's this password. What? Okay, well, we changed passwords again on Adobe, and I don't know the new one, so. Wait, does that mean I can't edit these files? Yeah, I can't use Acrobat. It's not letting me use Acrobat, bro. Oh my gosh, bro. Well, I guess we're not gonna start this homework then, because Adobe Acrobat does not work without me logging in. And I don't have my password. I don't know my password. ATM. So let's just connect to this. We'll do that. Once I get the Adobe password, then I'll do that. So let's do this first. What are we saying? Why don't I just use Windows? Well, I would run into the same problem in any case. Like when I'm out and about, I'm not gonna have enough compute to be running like these things. Like I need a huge RTX GPU to do any of this stuff. So I need to connect to my Arch PC. So I could have a Windows laptop, but I like Unix-based systems better, and Mac OS I feel like is just superior in IMO. Yeah, it was Cursor. It's a VS Code wrapper. You have an Adobe license? Yeah, I do. They charge for subscription cancellation? I guess I'm never canceling my subscription. Okay, I need to do some work, bro. I've been super lazy recently right now. Okay, so let's do this exam review. No, that doesn't seem fun. What is on my to-do list, bro? I said I was gonna do this, study for my exam. I need to make my formula sheet for my exam. I need to study for my exam on Thursday. I need to do my homework that's due tomorrow.
super important. I only have 3 days. Oh my gosh, okay, it's fine. We'll crank that out later. Oh my gosh. Oh my gosh, bro. I just found out what the Adobe password is. That has to be the most ridiculous thing I've ever seen in my entire life. That's actually insane. Bro, my AirPods just died. Oh no, they didn't. So why'd they disconnect? Okay, we're gonna just charge my AirPods real quick. Take like 20 seconds. Okay. Bro, the password is insane. Bro, that is the most ridiculous password of all time. Okay, now I have Adobe Acrobat. Now I can do, yes, see, there we go. This is how I do all my homework assignments. I make 5 pages, or however many questions there are. We get rid of all this nonsense that they be putting on the homework. Just complete nonsense. We don't need any of that stuff. Just waste space. And then we go in reverse order. Every question gets its own page, so I can do it on my iPad. Okay. Get rid of this nonsense. This is the most superior way of doing homework of all time. You don't need Acrobat. You could probably use, I'll have to duplicate that. Probably use some open source version. I don't know. I'm not familiar with any of them though. Let's get rid of that. Perfect. Question 2 is gonna go on this page. What the hell did happen? Let's get rid of question 3. Let's get rid of this nonsense up here. And I think this figure is useful for this question. Yeah, figure 1 is in the question. Like here. Perfect. And then just move this to the top of the page. And then they do want you to add page numbering, so we can just do that real quick. This is page 3. Wait, what's the best way to do this? Let's just put this here. Let's just copy this. Put it here. Okay, and then we save that. Alright, so it should be all good. We have all my questions. They each get their own page. Perf. Save, close, airdrop this to my. Alright, bro. Dude, this is actually what's annoying about Acrobat is that it's really slow. Like it freezes sometimes and does all this nonsense. Let's go to my iPad. And then we get it on my iPad, import it into Notability under Physics. Perfect. And then I know question 5, you see it takes up the whole page, so you're gonna have to add a page below that to do the work for it. But now I can do all my homework. Consider a star of mass M, its density of R as a function of its distance. Okay, show that the gravitational percentage of energy of the star is blank. Oh crap. Bro. Now I see why they gave us 2 weeks to do this homework assignment. It's due tomorrow, by the way. I think I'm gonna do that later because that seems like a big brain activity. I don't really have the energy to do that right now. Adobe sucks. I love Adobe, bro. Adobe products are the best. You don't use a password manager? Yeah, but when the password changes and I'm not the one that changes it, then I have no choice. I share Adobe with my family. Guys, let's create a Discord. Yeah, let's create a Discord. Wow. Oh, someone texted me. Should I pull up the study? That's good. Okay. Just throw my phone over there. We don't need it. Let's create a Discord server to study. LOL, bro. Look in the description. Can you continue streaming every day now? Hell no. No, I talked about it earlier, like my schedule does not allow for that. Abukar, bro. The GOAT. How you been, bro? How am I? I'm chilling, bro. How you been? Yeah, Ollie's always here, bro. Ollie's the GOAT. Okay. Let me do something, right? Oh, GPT added some stupid stuff down here. Get that out of here, buddy. Get that out of here, buddy. Should we triple view? Okay, so let's just make this farther away so I can actually see what's going on here. So we can just write it in here and then I'll move it over to the other doc after. So, exam format. 3 problems, no electronics, formula sheet, both sides, okay. So it forgot these equations. Let's just throw these equations on here. Back E, not nabla, but close. Well, actually not close. 1 over 4 pi epsilon naught. That's also wrong, but it's trying. Row of R, there we go, good job. Good job, alt tab. Or not alt tab, just tab, I guess, that's just what they call it, just tab. D tau prime, / vec, script R. Okay, there we go. Guess just add a comma, / vec, force equals, nope, that's too much information, we don't need all that. There we go. Good job, buddy. Okay, let's see.
Ollie has a job, bro. It's insane. Why is my response time so delayed? I just don't really I'm not looking at chat frequently enough. I think it's just the frequency that I look at chat is what causes the delay. There should be no delay. Like if you send a message now, I'll read it immediately to show you what the real delay is. Did you move rooms? I moved apartments. I'm in a new apartment this year than I was last year. I remember yo, no delay check. See, I told you, bro. Told you, there's barely a delay. I don't know, it's probably milliseconds. I remember you had a Discord way back when you used Ubuntu. Did it get deleted? No, it's in the description. Oh, that link might not work though, you're right. That link might not work. Oh no, it works. The link works. Do you guys code in classical mechanics? In my class, we code in Python to model some of the problems. Yeah, I mean you have to. Like you have to use MATLAB for a lot of the problems because they give you like these integrals that are literally impossible to solve. And so you have to use code to solve them. Or ChatGPT. Either one. I use GPT, but a lot of people use code. Yo, no delay check? No, I'm just trolling. That's a pretty bad delay. Alright. Ali Guliev bullied Abukar, bro? Oh, hell nah. What do you think of the Palestine-Israel situation? Wow, we get some heated questions in my study stream, bro. Nah, it's valid. It's a precarious situation, to say the least. Yeah, I mean, I have a lot of comments about it, but I don't know what to say. I mean, just if we look at it objectively, like the killing of civilians is wrong, right? That's all I have to say, really. I mean, that's all there is to say. But the situation is very nuanced, so it's not like there's some easy solution to that statement, right? There's a lot of history behind what's going on there, and then there's a lot of things that currently are happening that impact, you know, the ability to start or stop the war, you know? So, there's a lot to deal with. My bad if that was a harsh question. No, it's not a harsh question. It's just loaded. It's just like a loaded question. It's like playing Russian roulette, literally. Your answer. Mr. Big is gonna agree. Yeah, no, Mr. Big's opinion on this situation has to be one of the worst opinions I've ever heard in my life. Bro, what he be saying in the Discord is like insane. What did he say, bro? Like, I'm not even trolling. Like, I believe in free speech and shit. But like, you'll never catch me saying what he said. Like, I can't even repeat it. I can't even repeat it, bro. Like, I'm not gonna lie, bro. It is bad. It's really bad. I know it's bad when you say free speech, not for real, bro. Nah, bro. People be saying free speech and then just say anything. It's kind of crazy. Just be saying anything, bro. Oh, hell nah. Okay. Here's a high symmetry. Gauss's law is useful for finding the electric field. Surface E.dIQ enclosed epsilon naught or grad dot V. Grad dot E equals rho over epsilon naught. Electrostatic potential. Grad cross E equals 0 for a static
charge distribution which implied in the existence of a scalar potential V that can be related to E minus grad V. VR, yeah, that's fine. Yeah, that's fine. Okay. Yes, so it forgot that equation. After Poisson's equation, we should have backslash text or V of vec R equals backslash frac first and then int, yes. Perfect. It's correct. Okay, it's got energy and work. We also relate, wait, hold on. Yeah. We also, what is this? They're just making stuff up, bro. What does this have to do with energy and work, bro? Begin equation? Who uses that either? You can just do double dollar sign. Bro, what is he talking about? What is he talking about? Why did he just bring this up in out of nowhere, bro? Right. Okay. So this is not what it says. We also could relate the work or energy to the scalar potential. Let's just say scalar. Bro, I can't type. And electric field. Yeah, it's close. That's not what I want though, actually. No, it's not a sum. Yes, that's what I want. Okay, and then this integral is over all space, so let's do, what's the thing called? Underset. All space. All space. Okay. Yes. Rho v d tau, and then this is also equivalently equal to backslash frac. Bro, what the hell is that? Epsilon naught. Yeah, bro. Why is it always? This is why tab sucks, bro. Like, what is he even talking about? It's just making stuff up at this point. Why didn't you just do that from the beginning? Like, see, it knows the equation, but it just chooses to say some nonsense. Okay, it just forgot. Okay, no, it didn't. It added most of this stuff. E0 inside conductor, rho R0 inside the bulk, and E0 inside on the surface. Any charge must lie. Okay, so this is wrong. Okay, so we have an item here. Any charge must lie at the surface of the conductor. Conductor is equipotential, obviously. The field in a cavity. Oh yeah, perpendicular to the surface, okay. The field in a cavity is 0, even when the conductor is placed in an external. Provided the cavity contains no free charge, that's what I was gonna say. The charge is placed in such a cavity, and the conductor looks charged from the outside. Correct. Okay, we define capacitance between two conductors that quantify. Okay. Oh, between two conductors, the capacitance will try to change the charge. Huh, I didn't even know that. Charge on the conductor, potential difference between conductors. Okay, let's go here. XX text, where Q is the charge on the conductor. There's a potential difference between conductors. We next considered how to find potentials using Poisson's equation. Yup. To find B in a region, decide whether Poisson's equation or Laplace's equation, where rho is 0, applies, write down the boundary conditions. Okay, yeah, this is right. Down boundary conditions. Typical boundary conditions. Dirichlet conditions. Specific normal derivatives. What? Okay, that's a terrible way of writing that. Genuinely, it's like the worst way I could ever think of writing that. I'm gonna change that. Method of images satisfy boundary conditions using fictitious charges outside the physical region. Sure. Canonical example: grounded plane, point charge Q, point charge minus Q. Yeah, I mean, method of images might be the easiest thing anyone's ever done in their life, so there's no point to fret over what it has written there. So this is the stupidest way of writing it. There, that's a better way of writing it, but that's also wrong. Minus, and this is above, and that's below. And this is a minus. Dang, bro, it's getting all these Johns wrong. So the minus outside the fraction. Okay. Dirichlet conditions. Let's actually write those out, please. Not item. These don't need this is an item. Let's just do like that. And we'll say V access infinity. I already know all of these, what they're supposed to be. And it's different for the setup, right? So there's no universal V of infinity. Well, V of infinity is typically 0, but there's special cases actually. V of 0 is typically, it depends. If there's a conductor at the origin, then it's 0, right? On the surface, there's usually actually some crazy situations. Right. Okay, perfect. So let's actually move this entire thing over, this new chapter. Move this over to my lecture notes. This is my real document. And I typically tab everything. Okay, perfect. And then let's get rid of this whole chapter. This whole bloat chapter. This is the Windows equivalent. The chapter version of Windows, which is all bloat. This whole thing. Common math. Right, where's the table of contents? Oh no. Where's common math? Yeah. Chapter 12. So we go from separation of variables, common math, homework solution. So this is separation of variables above it, right? Separation of variables, yes. So we just delete this entire thing. You don't want that chapter. Okay. And it should free up some space. And now we have exam 1 review, I should specify. Exam 1. Okay, and now let's take this. Now it's super easy. Like we can just take these 2 chapters only. These are the only chapters we need. Yeah. These 2 chapters. And we can go over to this guy. Get our thinker. Okay. We should tell him the definition of script R because that's a custom. It's a custom variable. Oh, this might be too long for it actually. It might be too long. I might have to have cursor do this. It might be too long. I don't want it to be verbose, honestly. Let me think. Is there anything explicit that I need? Okay. Let's just see what it writes, and then after we can ask it to make revisions. So it's not too long, thankfully. Thought the message was gonna be. They've been making the cap for messages like much shorter. I don't know why. It's really strange. It's like they don't want people to enjoy their service. Technology. Technology, bro. Are you still doing that project where you made a website to see what courses you have in uni? Oh yeah. No, I'm not still working on that, but it exists still. I actually could update what I have. Fall 2025. So I'm actually not taking. How do I remove courses again? Oh, dropped right. I am taking. What class am I taking? CS 446. ECE 398. Physics 325. Physics 435. 1, 2, 3, 4. Okay, Chem 102, Chem 103. One, 2, 3, 4, 5, 6. So I'm missing one course, which is. Oh. I dropped it actually, but I might add it back. Yeah, there's a little error. There's like little problems here. Like this should be 3 to 4. Like this is 0 to 4. This one should be 3 to 4 credit hours. It's really simple. I'll just adding into the code, just like a dash in between double-digit hours, because there's no such thing as a double-digit hour course. So if we somehow get to that situation, we can just throw in a dash. And then I also have to update the data for GPA, but I'm not doing that. So
It's not gonna get updated. Prereq highlighting shouldn't change. I mean, they changed their prereqs, so I might have to rescrape. Like, I would have to rescrape the university website to get the prereqs again. And then degree program, yeah, it's not even filling anything out. No courses added to this requirement yet. Like, that doesn't even make sense. Oh, I have to add it myself. Oh, yeah, it doesn't automatically do it. Oh, that's so annoying. Yeah, I'm not doing that. That's so much work. But I have mostly all of this stuff completed, actually. Mark that one as completed, though. And then we can add spring 2026. I already know what classes I'm going to take there, so. You made that, right? Yeah, I made this website. Oh, no. Bro, I always do that. I mean to press Command W, then I accidentally press Command Q. And it closes the entire app. So trash. Like, obviously not what I wanted to do. Oh my gosh, now my window over here is closed too. Okay, do you still, what alright, peace out guys, I'm a dip. Alright, see you bro. Where did you get your shirt from? It looks nice. I got it from J. Crew, maybe? Yeah, J. Crew. It's J. Crew. You still drop clothing? I mean, it still exists. It still exists. Please don't order anything, because I'm the one that ships that stuff out, and I'm obviously at school, so I don't have any of the hoodies or anything. So there's no one to ship the clothes out. So it still exists, but fingers crossed no one places any orders, because they won't get their clothes for like 2 months. Wait, what is that AI that understands code? It's Cursor. It's the GOAT. Oh, ChatGPT. You still play hockey? I don't. I do not still play hockey, unfortunately. What are you working on? Currently, I'm slacking. Off. That's what I'm working on. Then what happens if I buy one? LMA, are you gonna scam me? You won't get it for like 2 months. I mean, you can buy one if you want, but if you want your clothes, like, you go to the gym though, right? Yeah, I went to the gym before I streamed today, this morning. And then I run pretty far, usually half a marathon, like in one run, usually. Training for a full marathon, so still got a long way to go. Since when you were D1, do you no longer get a scholarship for hockey? I never got a scholarship for hockey in the first place. Yeah. I never got a scholarship. I walked on to the team. No, work-life balance is valid, but I don't really need it right now. But yeah, I don't play hockey anymore. Why don't I play hockey? It wasn't my decision. It's because the coach, well, actually, I can't read his mind, but I assume it was because I wasn't really that locked in on hockey. You know, it wasn't my main priority, and it shows like in your performance and how you act and stuff. So he just wanted a team. I presume he just wanted a team that was, you know, full of people that really love it. Which I loved playing hockey, but
school came first. Like, it wasn't my number one priority. And like, when you're playing the sport at a high level, like, it has to be your number one priority. Otherwise, you're not gonna play as well. Are you in any clubs? I mean, technically. Technically, I'm in clubs, but I don't do, on a day-to-day basis, I do absolutely nothing for any clubs. Can we see your calendar? Yeah, but it doesn't have, like, all my stuff. It just has, like, class. That's it. I don't really put anything else in my calendar. Just, like, some of my meetings and then class. It's not even all my meetings, actually. But it's just some of the meetings that I have, maybe like some exams or something. I have 2 exams next week, here and here. But yeah. I have like more stuff typically going on every day than is on my calendar. I just don't really have time to like make it stupidly large, or like spend a large amount of time on my calendar, right? So can we see what GPT was? Well, actually, I'd be asking ChatGPT like all sorts of things, so we're not gonna leak my chats. Yeah. But let's see. Oh, this is a new thing, or at least I've never seen this before. This is the canvases. Yeah, it's a canvas. Interesting. They have a new view for the canvas. I don't really like it, but it's fine. Bro, are you freaky with GPT? Nah, if I was asking some like crazy question, I'd do it in temporary chat, but like I'd be throwing in API keys and stuff, so we don't want to leak anything. It's just not worth it. It's not worth like showing you guys. Is D1 high level? Yeah, but the D1 that we have at my school is not the highest level. That's what I was saying. Yeah, Ethan, you're right. Gen Chem is so light compared to those classes. But Gen Chem is like supposed to be super hard. But compared to my other classes like that, it's so light. Like, it's not even funny. Like, I'd study the day of the exam only. If I did that for any of these classes, like, I'd be so cooked. What job do you have? What job do you have outside of school? I have a couple jobs right now outside of school. But yeah. And then over the summer I have even more jobs typically. But yeah, maybe next summer I might not add more jobs. Yo, the Glaze is crazy kid on the internet. I know you have some dodgy combos with ChatGPT. Yeah, I'll admit it, bro. Some crazy combos with that guy. You watching any anime? I'm watching Don right now. Don season 2. Except I watched season 1 super long ago, so I have no idea what's going on. Thanks, gang. Thanks, Abukar. I've watched so many anime though. Do you watch anime every day? Depends. Well, I mainly watch anime like at the end. Well, actually, I only watch anime like at the end of the day. At night, right before I go to sleep. So it cuts into my sleep time. That's how I make time for it. Usually I designate like 10 hours outside of work for like rest and sleep and stuff. Like, so I do like 2 hours a day with exercise, every other hour is working, and then 10 hours like sleeping or something. And so I'll cut into that time to watch anime, maybe like 2 episodes a night or something. You reading any books currently? No, I'm not. My brain is at maximum maximum, I guess, like, I mean, how do you quantify like the rate of change of information in your brain? It's maxed out. The graph is what? The second derivative is 0. I'm kidding. Yeah, I'm not increasing the amount of information that I put into my brain every day. Compare, like, just besides for the stuff that I usually add. What browser is this? Is Arc. You watch anime before going to bed. Isn't that bad for your eyes? Yeah, I mean, I don't notice anything. I also don't really care. My sleep is really good, so. I watch it on this screen actually while I sleep, like, and laying in my bed back there, so. I don't know. Do you have a girl now or not? No, I don't. I'm just chilling. I just ask it stupid questions like, how can I manipulate everyone with one trick? Oh my, that's a temporary chat for sure, bro. That's crazy. Alright, let me listen to some actually good music. Let me get this nonsense classical music out of my ears. Nah, I mean, I'm kidding. Classical music's good, but like, I need some stuff that's hype AF. Bro, I can't even like sing along. I'm gonna get copyrighted. Damn, I just went to bed and woke up. Bro, still alive? Yes, sir. The classical music help you study. Okay, I can't talk and listen to this music at the same time, actually. It helps you. Yeah, it can, but I mean, I've been studying for like 8 hours now, so I gotta switch it up, you know? Do you listen to Tu Hollis? I don't know what that is. I'm listening to Bohemian Rhapsody right now by Queen, if you've ever heard of that. I listen to also a lot of unreleased Juice WRLD, and I started listening to some country recently. I like country music. Yeah, just basically anything but like rap. I don't really listen to rap that often anymore. Maybe like Drake or Kanye or Kendrick or something. Or J. Cole. But what's your favorite unreleased Juice WRLD song? It depends, bro. I have some sauce, bro. You wanna peep my playlist, bro? Dude, I really gotta get back to work, but let's just do this real quick. This is my playlist. This is my Juice WRLD playlist, bro. Look how many songs it has in it, bro. It has so many. It has 1,047 songs. But my favorite Juice WRLD unreleased song, I don't know. My current favorite song right now is this one that I just added to my playlist, Better Off Alone. But all time, like Victorious is fire. I don't know what I would say is my all-time favorite. He's an underground warrior. I don't know who that is, bro. You like Coldplay? Oh, I love Coldplay, bro. No, I'm listening to the stream in my headphones. Like, I can hear myself and the classical music. But I just wanted to, I've been listening to it for 8 hours, so that's what I was saying. I was like, bro, I'm low-key tight. I'm low-key tight, bro. Like, I need to switch it up. Rental's my fave. Yeah, Rental's fire, but it's just like, it's kind of like mainstream. But Rental is fire. Alright, Aidan, lock in. Yeah, you're right, bro, you're right. Let me play Bohemian Rhapsody. I can still hear the classical music, but I'm playing it on top, so there's like a lot going on. I gotta stop talking, because brain's cooked. Okay. Okay, we don't need to write that. Yes, like these are useful, but these are kind of on the equation sheet already. Bro, this song is so good, bro. Now let me put you on chat. What is this? I don't even know what that is, bro. Bro, like with this equation sheet, like what is even the point of taking the exam? The answers are right here. This is dead ass, like, this is so fire. Bro, there's literally no point to take the exam, bro. Oh my gosh, this is cheating, bro. Okay, bro, that's not gonna fit on 2 pages, bro. Okay, we don't even use this. What? Why doesn't it? Does it ever work? Why would it put energy? Which makes no sense. What is it talking about? Why would it do that? It says energy, pressure, work, and then doesn't include work. It includes the energy, but like we don't even use that. What is insane? How do you spell concise? It's fine. What work energy equivalents? Yeah, I know, but like, okay, I literally can't. I can't hear. Yeah, I would just rather have like the explicit formulas for work written out. Right, like this, we should definitely have this easily. And then also like for a point charge. Failed to edit, bro. Lock in. The integral with the circle around it? What? This? Wait, this? Like Gauss's law? In Gauss's law? It's a line integral. It's an integral over like a path, closed path. Or in some cases it could also be a surface integral. Did it fix what I said? Oh yeah, here. Okay, did it fix it? I said, but what is this? Is it rebooted, bro? Is this like LaTeX or is this Markdown? This is Markdown, bro? I need it in LaTeX so I can control the length of it. You think this is 2 pages? Is it gonna download, bro? Did it download? Oh. What's going on? Wait, what? Okay, whatever. Because we don't get to download it. The heck, bro? Did it download? No. Yeah, it's not downloading. Maybe because it's currently typing. I don't know. Let's just how many pages? Oh, it's 2 pages, bro. It's totally 2 pages. Bro, GBT's the GOAT. Bro, I don't think I can just print. I don't think I can print this out and bring it, right? Like, that doesn't make sense. Like, it doesn't make sense. Like, all classes ever, they explicitly say, they're like, oh, you can't type, like, it has to be handwritten. But look, they just say, you will be allowed to bring your own single-page, 2-sided formula sheet. You will be provided this formula sheet. And if I go, that's the only exam information, by the way. And they gave information in lecture, but they said, you have access to a provided formula sheet and 1 sheet, both sides, that you can write yourself. It doesn't say anything about like handwriting. Yeah, but I don't want to do that, bro. Look at all this stuff, bro. It's gonna take me like 2 hours to copy all this information down. Bro, look at this nonsense, bro. Do you see that? Chat, are you seeing this? If I could just print this and bring it, like, that's goated. You know how tedious that is to write all this handwritten? I guess I should, though, just in case. And then I'll bring both. Yeah, it guarantees, yeah. It guarantees, yeah. Oh my gosh. Okay, I'm gonna bring, look, this is what I'm gonna do. I'm gonna handwrite it, right? But I'm gonna bring both the printed and the handwritten, and I'm gonna use the printed, right? And if they say something, then I'll just throw it away and use my handwritten one. Like, I'm gonna go, like, right when I get there, I'm gonna ask the TA or like the professor, I'm gonna be like, okay, can I use this equation formula sheet, the typed one? And they'll say yes or no. And depending on what they say, I'll use my handwritten one. But the thing, like, the reason I'm gonna do that is because if I can use the types, then bro, the next exam's like I'm chilling. Except the final is gonna be like so cooked, bro. Because I'm not gonna be able to write that much information down on 1 sheet for the final, bro. Bro, we did not have the same stuff, bro. You did first year electro, like, just physics 2. This is 2nd year stuff, bro. I saw the course that you took, bro. Like, last year when I took my first year Electrodynamics, we could not bring a formula sheet. But like, bro, we are allowed to bring this sheet. Like, people bring sheets that look like this to the exam, and the average is still a 70. Like, the exams are cooked, bro. They're so hard. But I should be chilling. might give you multiple sheets for the final. I don't know. They don't say anything like that. But there's literally no other exam information. Like, that's what I'm saying. Like, they can't get mad at me for bringing a thing, because they literally don't say anything about it. I was in lecture when she said it, and it was like, I should have asked. Okay, I gotta do this physics homework, this 325 homework though. This is like orbital motion. It should not be on the exam that we have on Thursday, but I think it builds off this stuff, so it should help me either way to have this info. I gotta think about how I'm gonna do the work. You can memorize all of those? Yeah, I have most of them memorized, but it's just like the exam's only 50 minutes, so you can't really like spend time trying to think of like stuff if you don't remember it like immediately. So that's what. Yeah, I think it is somewhat similar. Well, the stuff that I'm in is just like a build off of what Physics 2 taught. Is your exam tomorrow? Yeah, my exam's tomorrow. You think you'll ever be a TA? Possibly. It's free tuition, right? Have you ever take real analysis? I might take real analysis next semester. Elementary real analysis. We'll see. For fun. Okay. It's so stupid, this homework assignment. It's gonna be so dumb. Yeah, I don't know why Mac like doesn't provide a window manager out of the box. Like, look how bad the quality is on the UX plan. Oops. Just had a segmentation fault. I just got a seg fault, bro. What was it, intro to C++? Yeah, we get it quite unexpectedly. Dang, that is like low-key leaked all the information about my iPad. Like literally everything. Every sensitive like string or number associated with my iPad is right here on the screen. Okay, I guess I can start this homework before while that's loading. Except I'm gonna be real with you, bro. I do not know the answer to any of these questions. I don't even know where to start. Consider a star. Okay, this obviously has to use like just some standard formula for gravitational potential in relation to the density. I don't really remember this lecture though. P? Rho is the average density, yeah, so there's rho but not P. Okay, let's see. It might be in gravitational. If it's in this lecture, I'm low-key cooked because then that means it might be on the exam. Ah, crap. Oh, crap. But you know damn well this is about to be the most insane integral of my entire life. Yeah, holy crap. Office hours, here we come after my exam tomorrow. This is insane, bro. How is this supposed to make any sense to anybody? What is this taking so long, bro? Okay, there we go. Why's okay, well the quality's still garb, but it's better than nothing. Oh, the presentation quality is not as bad. Wait, how do I change like what gets presented? Quality is just gonna be bad. Alright, so how many exams you got? I feel like you always have one. You want to see how many exams I have? This is my exam schedule. These are my exams. That's my exam schedule. You know it's cooked when they say, hint, you may need the following integral. I just submitted the ultimate prompt to ChatGPT to have it tutor me on my homework. Like, that is unmatched. Oh, hell no. Why do you have so many? I know, bro. It's my teacher, bro. Chem 102 has 6 exams. Like, what the F? How is that even legal? Should be illegal, right? She should be put in jail. No, I'm just kidding. Those exams are hella easy, so it's chill. Okay, well, I can't answer this question until GPT teaches me. What's EC404? You can Google it. EC404 UIUC, but I'll also tell you. It's quantum information. Yeah, 7 courses can be a lot. I wish like maybe 3 of them were gen eds. Then it'd be like a little bit easier, but it is what it is, bro. You gotta do what you gotta do. This is all I can do. Like, I can just mess around until ChatGPT teaches me how to do my homework. Wait, anyone wanna forge my signature? I just like scribble, like literally. Just need to get like a letter, like one, just the first letter, and then you just scribble. ChatGPT has spoken. Okay. Okay, I haven't even read the problem. Consider mass. Okay. So we have the mass. Okay, it's less dense. This is a pretty realistic situation, except the function probably wouldn't model like that well, but gravitational potential. Okay, so we have a spherical star. Its density changes as you change the radius, and we want to find the gravitational potential of the star. Okay, so we know this is a uniform spherical mass. Oh well. Yeah, I mean it's uniform in shape alone, and it's symmetrical. Exploit symmetry. For a spherically symmetric mass distribution, only the mass enclosed inside a radius r matters for the field at r. The field is purely radial, yes. What the heck is that, bro? Is that in my note? Is that in the lecture notes, bro? Or is he just making stuff up? We just making stuff up, bro. Oh, yeah. The total shell mass is m equals, yeah. Okay. So, let me turn this sideways. Oh, I guess not. Ruins things. Okay, so we have m is going to equal 4 pi rho h big R squared. Right. So we're just laying out the facts. Hold on. And G Bro, my ChatGPT answered B before it answered A. That makes no sense. Okay, the derivative of phi with respect to R. Oh, G, yes, G. This is exactly what I want. A planet. Bro, where's the general formula for that? Like, hello? Oh, here it is. Oh, no, it's not. Hold on, let me just... We want little g... Where does he get this equation from? I don't see it. This is definitely the right... Yeah, it's not gonna be in this one, bro. Oh, well, that is actually what I'm looking for, but that's just a usage of it, not the definition. This also doesn't even have phi at all. Oh my gosh. This class gives me a headache, bro. Oh. This is kind of the definition. Like we have d phi. No, it's not a partial. Plus minus g. Oh, the arc, the component of G. Or not arth component, but the R component of G, of little g, of the potential. I don't even know what little g is, bro. I don't even know what little g like is. Like, what is that? Gravitational acceleration. Nice. Bro, GPT says this equation that he's using is right, but I don't see it. I mean, it is the same as this, but still. See, well, this is for R is greater than R. fun. We can just. Okay. So this is gonna equal. GM over R squared. Right, these are just the facts. Like, we're not even solving the question yet. Okay. H. There's a lot of noise going on out there. Wait, is this a cylinder or something? Right, like, why is this, why do we have H? Bro, this is nonsense, bro. Wait, what? Okay, I'm giving him my lecture notes. Like, it has to. Like, I can't just be using the information that ChatGPT pulls just out of nowhere, bro. I'm not gonna understand this, bro. Yeah, like, I don't know. I hate this class. I'm so cooked, bro.
You realize how fried my brain is right now, bro. I can't even like think straight. This class is cooking me.
I have an exam tomorrow morning.
Can function, and these questions are going to be even harder. Except these ones are a little bit more intuitive, at least.
Bro, why did class just become impossible? Okay, it's giving me information that it claims is straight out of my lecture notes. Yes.
So we know this. Yeah, I know this. Yes. I see. Equation sheet.
Force to field to potential. And that's to find the gravitational field of a distributed mass and then introduce the potential so that blah blah blah. They emphasize that working with the scalar potential obviously lets you directly. Absolutely.
Yeah. So this still holds true. Since we have, let me just write this all in one line. Since we have spherical symmetry,
So we have the shell example. So they give a shell. Yeah, gravitational potential of a mass shell is exactly basically what we're doing. We derive
derive that G equals something. Little g, where is it? They don't just derive anything, but what are we chatting about here? Show that outside a thin spherical shell, the field is as if all the mass were at the center. Oh, this is just like potential energy, like or electric potential with the electric field. Outside a thin shell, the field is as if all the mass were at the center, and all the charges at the center. Inside a shell, the field is zero. This is literally electric field, bro. Superposing shells gives the working rule that you were taught. For any symmetric row of R, the field at radius R depends only on the mass enclosed inside R. Yeah, the thing is, we're not given that equation, bro. It's just making that up. Like, there's no little g here. It's defined here, but that's it. This guy. Bruh. Every G in the entire thing. Yeah, I knew it wasn't gonna find. It's not gonna be. Why can't I copy this, bro? Oh, I guess you can. There's only one. There's only one instance of it. I doubt it's in this. Right? I didn't think so. Yeah, they also don't use little g. So where does that equation come from, bro? Okay, let me just read this whole section. Okay. Yeah, this doesn't explain jack, bro. Okay, well, let me cite my sources. From ChatGPT, we have G of R supposedly equals minus big G, big M of S divided by R squared, obviously radially outwards. At least that part I understand. with apparently m of s equaling 0 to tau 4 pi s squared rho of s ds. We use Shell/Gauss's law for gravity method highlighted in the notes. Yeah, that's not in the notes. I don't know what I'm talking about. None of this is in the notes. Poisson/Laplace's check. There's also give. Okay. Let's just write this up here. Laplace's equation for gravitational. This is crazy that it's literally the same thing as electrostatics. No, we gotta do A first, bro. Okay, this is just background information, so we're not even doing A yet. Okay, A, we're gonna use this one, G equals minus grad phi, right? So this is equivalent to d phi dr equals kind of jumping through hoops here a little bit because this crap is not on my lecture notes. But why does he just work through examples? Like, why don't we do the actual? He only mentions little g once, and it's up here somewhere. Like once. We only mentioned it once. Where is it? Hello? Yeah, there. We only mentioned it once. You don't even give it like a real definition. You just say minus grad. And then we don't ever see minus grad. It never takes a derivative with respect to r. It's just this differential, which literally means nothing to me. Like, what is this differential? Let's see. Yeah, well, we don't want to consider a non-spherical case because we're working with spherical. Okay. Yeah. So this is literally like electric potential. So this gives us this equation, phi equals the integral of gm over r squared plus a squared dr, right? Apparently there's a constant out here, but we can do that after we integrate, buddy. We don't need to do that now. Okay, this integral is actually really straightforward. We just have phi equals
equals, isn't it GM over A? Yeah, everyone knows this trig identity. Arctan of, what are the bounds? Oh, I guess there's no bounds. It doesn't matter what the bounds are. R over A. And then we add plus some constants. And this is going to be evaluated at some bounds, but we don't have any bounds right now. Okay. Now what did we want to prove? Pi minus 2 arctan. Oh, we're just setting C is equal to that. Okay. Oh, we're integrating from 0 to infinity. Let me integrate from 0 to infinity. Let me integrate from 0 to infinity, because then we get GM over A outside of 2 pi, right? No, sorry, not 2 pi, pi over 2. We go to pi over 2 at infinity, at 0, arctan of 0. Wait, arctan of 0 is not pi over 2. Arctan of infinity is pi over 2. Oh, we're integrating R, yeah, not A, sorry. Yeah, and then this is going to be minus arctan of 0. Wait, why? Okay, let's just have some variable R, and let's integrate with respect to R prime. But why is my writing so big? Let's put brackets. We no longer have plus C, bro. Is that a problem? What does it want the answer to be? Okay, so we're missing a minus sign. And the but we're not missing a factor of 2. I'm missing a minus sign though. Where does the minus sign come from? ChatGPT says we have some constant that we set equal to minus pi GM over 2A. What's the need for that? Should I just throw a minus sign? like, should I just throw a minus sign on here, bro? Like, what is the point of not doing that? Like, shouldn't this be the right answer? If I just throw, like, literally, if I just throw a minus sign on here, it's canceling out the background noise pretty well. There's people here talking. And then this is obviously, like, we don't even have to write this, but it's obviously equivalent that's our solution of part A. Bro, I really have an exam in like 12 hours. BS, bro. Not in this class, thankfully. Holy crap. I would be beyond cooked. Okay, find the gravitational field G of the star. Oh, they give us the integral. I didn't even realize that. It's literally the simplest. Everyone knows that integral, though. Why did they give us that, bro? I didn't even realize that. Okay, let's do part B. So this is what we need to steal for part B. We low-key don't need another page. I could do this all on one page. If I just work small. Dude, the noise canceling, I think, is really good. Can you guys hear the people? Oh no, you can hear the people in the background actually pretty easily. And sometimes though. Okay, let's see. So we're given a row, obviously. No row. Row. Gosh damn it. Can we? This is too thick. Pause. Right. So now we can solve the MS integral. It's like Legos, bro. I just built my integral. I just built my integral using Legos, bro. This is a straightforward integral as well. Let's pull everything out. Well, numerator we actually only get 2. And okay. We got r squared plus a squared. Wait, why is this recursive? Why does MS depend on MS? Okay, sorry. This is not. Yeah, I miswrote. I wrote this incorrectly. This is just we have a recursive integral. Oh yeah, that makes sense. What are we left with? Just SDS? That can't be right, bro. Oh, did I forget to replace something? Yeah. Why
was gonna say, like, there's no way we just take this whole complicated part of the integral out. Okay, this integral is still super easy though. Thankful. I was like, there's no way. Not in this class, we're not getting that easy of integrals. Let's set u equals zero. Okay, fine. We'll write it. We won't erase it. I don't really like minus signs. Let's just erase it. No, I'm just trolling. Let's just switch these. And we need a minus sign. Okay. Oh, facts. Bro, why can I not write M's, bro? Hello? Wait, GPT didn't use tau though. He used R. Oh, that was an R to begin with. I read it wrong. I mean, it literally doesn't matter. It's just convention, but... how do we simplify this? We say factor out an a squared maybe? No. Factor out an a squared. R squared, a squared plus 1. These cancel, you just get 1. That doesn't help me. Oh, you know how we can simplify this? Yeah. That's a better way of simplifying it. That's our final answer for our mass. And so we plug that back into our definition. have G, recall, G of R equals minus GM of S over R squared. And so this means G of R equals minus minus GM R squared over A squared in the R hat direction, obviously. And we can actually simplify, well, not simplify this, but just leave it to magnitude only. We'll include the direction in the vector, which I think is more precise. Okay. Oh, sorry. We gotta just establish this is our hat direction. So that's my answer. Heavily influenced by GPT, that is my answer. Bro, why do you kind of have to solve A first to get, or R first, or B first to get to A? Also, this is like the same. Like, we're just integrating with respect to R. That makes sense because we have... No, that doesn't make any sense. It doesn't make any sense at all, actually. So, wait, what? One, why the hell are you solving B before A, GPT? Also, is backslash capital Phi equal to backslash int of backslash vec G of R dr? This doesn't make any sense. I'd see Abukar. I looked at chat like right when you said that. No, this question shouldn't have taken me 20 minutes. Like, I just don't know the material, so it's like hella confusing. I'm gonna do the rest tomorrow, I think. I might do one more question. Almost put minus sign in the limits. G dot R. Oh wait, this does make sense actually. Phi is the integral of G. Yeah, what am I talking about? Yeah, that's correct. It's 100% right. Yeah, this is very similar to electric potential and electric fields, but this stuff kind of doesn't. Okay, the big main things are like this came from nowhere. It's not in our lecture notes, and also like all of this stuff came from nowhere. This is not defined anywhere, but I guess we can figure it out from here. See. actually draw an arrow to that so it makes a little bit more sense. Wait, so shouldn't this be positive? Wait, didn't I just randomly throw a minus sign on here? In the middle of the... Oh no, that was in question 1. Yeah, I just randomly threw a minus sign on this. Yeah, so it's not... Bro, gosh damn it. But then, how come... Oh, shit. I don't know. Oh. Oh, yeah, because it's supposed to be minus grad. So... Can't be negative. Wait, okay, I need to ask GPT, like, what I'm doing if that's incorrect. Okay, I integrated an A. Yeah, this integral, obviously. Minus. Bro, the people upstairs be stomping hella loud, bro. Yeah, GPT did an indefinite integral, and then you see. So he didn't even solve from 0 to infinity. Maybe. Oh, you know what it is? My frame of reference goes from infinity to 0. Right? It's from infinity. Oh no, R, sorry, not 0, R. Wait, hold on, I just told ChatGPT the wrong thing. I did R. Is it because the reference? Yes. Perfect. Okay, let's write the bounds correctly here. Infinity to R. And then I just did a minus. We can actually remove this minus. And we go from infinity to R. Yeah, then we don't even need a minus sign at all, ever. Just swap these. That makes a lot more sense. It makes sense. I don't think it's right, like what I'm saying. I think what I'm saying is actually wrong. But in any case, I'm gonna go with it because that is the level of understanding that I'm currently at. Great question. It's keeping from the definition of potential in your chosen limits. You know to use so long the deal we have. Is any component for this star plugged in infinity to R? Yeah, exactly. Yeah. So r to infinity would require a minus sign. Nice, bro. Makes sense now. Okay.
Yeah, we're not doing another problem. I still have to do, oh, I haven't even done my chem post lab. When does that due, by the way? Might have been due already. I mean, they're pretty easy, but. We don't have to leak. We don't have to leak anything, bro. My email's already publicly available. It's a school email, bro. They have really good filters now, so it blocks out spam and stuff. Already finished that. Yeah, see, I haven't done this. It's due on the 7th, so. Where's Notion? So add that to Notion. 103 lab. Let's put it at high priority. Let's move homework 5 to high priority. Oh no. Okay, so I am gonna be right back. I need to do like 2 things. So I'll be right back, but yeah, so I'll be back in a second. What's going on? Oh, I forgot. Okay, there we go. Alright, let me get some audio back. I've acquired a piece of paper
to write my physics stuff on. But I'm also going to get a piece of lined paper, which I have here. I have this thing. And we have some beautiful, beautiful lined paper in here. Nice and smooth. But this is like just plain paper. Oh, I guess we need a writing utensil as well. I think pen is better. Well, that means I gotta write slowly because I'm totally gonna make some mistakes. But because pencil is gonna get smeared. Is there a cat in here? I don't think so. I don't see a pen. It's so dark in here, though. What happened to the sun? Isn't it still morning? Oh, yes. Is this pen good though? Okay. Ow. This pen is decent. Let me grab a I have some really, I think I have some really nice pens actually. I'll be right back. Bro, I gotta up my pen collection. Okay, let me turn the lights back on. I hate fluorescent lights, bro. It's gonna mess up my melatonin production. Okay. All of my pens are from like career fairs or something. I have this company, I don't know what company this is. But these are like 3 of the best pens that I could find. This one in the middle, this black one, looks goated. It's like one of these. It comes off like that. Like the clicks are good, but they tend to have like dry tips. Pause. So let's see. Oh, this pen is like out. Or I guess it just hasn't been used in a while. Oh no, it's really. Oh wow, that's actually not out at all. That's legit. That's a legit pen. Not a legit pen. That pen is dog. That pen is dog too. Yeah, the pen that I said is actually nuts. Okay, I only have one piece of non-lined paper, so I'm gonna do the lined. I'm gonna use the lined paper first. So let's go and get my equation sheet. Okay, so we actually don't have to write like constants and stuff because we're never gonna use them. At least that's what I was told by the professor. She said like we don't need a calculator or anything, so there's like 99% chance we won't need like these constants, their values and stuff. That being said, bro, This equation sheet is, I'm excited. I'm excited to take this exam. Like with this equation sheet, bro, like I am like set for life. Like there's nothing. Are these your own notes? These are not. These are my notes here that I've taken. And these are just like screenshots from the textbook, these pictures. I just screenshot it from the textbook. He has some really nice graphics, like this pillbox is one of the best graphics I've seen. And like this is literally, like these are just literally screenshots. But this one that I'm looking at right now was generated by ChatGPT. So this is what he said my equation sheet should look like. I'll show you, I'll put you on to the method that I use to get this information from GPT. Said I wasn't gonna leak my chats. There's probably nothing crazy on there, but like, just like, so I put in all the information. I just put in my notes actually. You can see, I just put my notes, the lecture notes that are the notes that I just showed. I just put them in, and then it spit out this like thing. It's LaTeX. Bro, what freaky chat? Like, I'm not hiding anything. I mean, you can go see. I leaked it. Like, it's not really that big of a deal. Like, if you go pause or something, you can see. I just feel like it's not worth the risk. I mean, I'd be asking ChatGPT anything. I mainly use temporary chats though. But I did leak my IP address multiple times for my AI server too. 'Cause it's backed up multiple times. But still, I did leak my IP address. It's my public IP though. It's not really that big of a deal. Even my private IP wouldn't be that big of a deal, but if you got onto my home network with my private IP, I'd be cooked. How long are you streaming for? I don't know. I'll be done probably after I finish this equation sheet, and then I might crank out some things for my PhD applications. But other than that, yeah. What language? This is LaTeX. LaTeX. Okay, so let's write this equation sheet. We're skipping the constants. This is what happens when you do physics, bro. You lose your sense of English. I've just looked at integrals all day. Let me fix this. Because I'm gonna be pretty low, so I'll put my glasses back on to save my eyes from the blue light. Okay, so our first thing is the fundamentals, Coulomb's law, discrete. What's up with my Wi-Fi? I'm trying to think of if we need to.
Oh, frick. I just bent this paper by accident. Okay, time to get a new sheet of paper.
Bro, my equation sheet's gonna be perfect. Not a single wrinkle on it. Okay, wait, I have to think about how I'm gonna label all this stuff. Fundamentals? Do we want to call it fundamentals? I guess we can. Coulomb's law, discrete. We don't really use that, but, you know. We do use F equals QE. It's true. Okay, let's write this. So we'll label it fundamentals. So
Yeah, we'll label it fundamentals.
Should we number it?
I guess we could number it.
Right? Number? Yeah, 1. Fundamentals.
Bro, this pen is so good. Bro, I'm not even applying pressure with the pen. And like, it's like insane.
Insane. Okay, fundamentals.
Let's hit Coulomb's law.
I'm trying to think of how much we can actually fit on the sheet with my handwriting. We do have both sides, however. And the second page is like not completely full.
Okay. Let's just use the sides.
Should I use the sides of the sheet?
Let me see how that looks on a different piece of paper. Oh no. Okay. Bro, this is like the best pen I've ever touched in my entire life.
How do you spell cool? Am I really playing music that loud, bro? I can't hear it with my noise canceling, but I can hear it on the stream. Okay, I have no choice but to use the side. So I have to use the border. Bro, it's literally like a marker, bro. Insane. Trying to be as precise as possible. Although honestly,
I don't really need to be because I know most of this stuff already. So writing it is mainly just for a refresher. Uh-oh, that's bad.
okay, fractions, I might not be able to.
This is discrete.
And
Now we have continuous.
so for a line,
We have E equals, we're gonna use K. We're gonna start using K.
K equals 1 over 4 pi epsilon naught.
To save space, bro, because we don't have space to write all these fractions.
Dude, this is my best work.
Okay, we actually don't need to be giving every single one of these its own line. Right, I mean, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 28 lines on this paper. Like if we do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. We're gonna have to use like one line per thing. Yeah, okay, sorry. That was early. So, okay, we're gonna use another variable here. We're gonna use cursive R hat. No. Let's just use what's a good variable to use there? That's intuitive. Oh, big R. Yeah, they use big R. Oh no, big R is for radius, bro. Let's use, we don't want to use cursive R either because we use cursive R later. Or I guess not. Why does it never use cursive R? Wait, where's somewhere we know would use cursive R? Like this, the line. Oh, it's using a capital R. Yeah, that's stupid. We don't use capital R in this. Okay. This typically equals root r squared plus, like, say z squared or something. But in the event that our triangle is not a right triangle, we use the law of cosines. So we say r squared. Wait, what's the law of cosine? R squared plus z squared minus 2az, or 2rz, 2rz cosine theta. Additionally, we have root r squared plus z squared minus 2rz. Let's do plus or minus 2rz equals r squared plus or minus z squared. Oh, squared, sorry. Oh, no. And this is an absolute value. Okay. Sucks not being able to erase, bro. I need to draw this triangle, though. So we have this here. We have some triangle with an arbitrary angle. This is theta here. A, which is r in our case,
which is Z in our case, and C, which is what we're interested in, which is cursive R in our case. Okay. And now let's define another variable. Like, what's a random variable that I can use, bro? Gamma? I'm gonna use gamma. I'm gonna use gamma equals R minus R prime over the size of R minus R prime. Okay, this is kind of a stupid way of writing this. Like, if we look at this, like, line, where does he have this written? Here. What page was that on? It was up here. It's like right. Yeah, it's chapter 2. No. It's here almost. A little bit up. Where's 2.4? 2.4. Question 2.4 is before that. Yeah, here. Right, these are equivalent. I like the way the textbook writes it better. Backslash E. Oh yeah, what is it using? Strange. I'm gonna write these. Okay, I should have just wrote R hat, bro. It's the same as the text. I'm never using gamma. R hat. Okay. So, for a line charge, we have. Wait, what happened? For a line charge, we have K. Integral lambda of R. And we'll do vector and prime by R squared. Cursive R squared. In the R hat direction. dl prime. For a surface, bro, being left-handed actually sucks. I am ambidextrous, but my handwriting with my left is better than my right, so I use, which might be is that contradictory to being ambidextrous? Does that mean I'm not? r squared r hat dA prime. And for a volume, we have E equals K integral rho of r back prime divided by cursive r squared in the r hat direction, and this is d tau prime, where tau is some volume. Okay. And then we also have the voltages, or not the voltages, the potential for both, or for all. Potential equals, that's K, right? Yeah, K. K integral lambda r back prime dl. Okay. K lambda over r dl, sigma over r dA, rho over r d tau. Stuff's pretty much common sense, but I'm just gonna write it for the sake of writing it. The potential at V VB minus V of A equals minus the integral from A to B E dot dl. Wait, do we have V plus and V minus? I don't think so. I'm gonna write that because that's like not explicitly put anywhere, but it is like generally true. If we go down here to when we were doing potentials, V plus minus V minus. I might not be able to find it though. Okay, you know, the TA emailed it to me. So I can just pull up my email. And we'll go to sent. Fajardo. This is the equation we have. V of plus minus V of minus equals minus the integral from the negative charge to the positive charge E dot dl. For any charge plus Q. Oh, this is on conductors though, or not? I think it's only on conductors, actually. Yeah. Conductors. Yeah. Okay, where were we? We're here. Poisson / Laplace. This is, I mean, if you don't have that memorized, you're cooked for this exam. But it's okay. It's my first time ever writing a semicolon. Who writes semicolons, bro? Bro, I'm gonna smear all of this writing with my hands. I need like a napkin. This is why it sucks being left-handed. Yeah. This napkin doesn't smear anything. Okay, Gauss's law is like the simplest thing of all time. And then differential form. The curl just always equal to 0. Yeah. Path independent. Coordinate helpers, we don't need to write that because we already have it on our equation sheet that they give us. 2 results. We have point charge. E equals kq over r squared. Radially outwards. Where r is just our distance from the point charge. Voltage equals just kq over r. Why do I keep saying voltage? Potential. A dipole? I don't know what it's talking about. P equals QD. Three P dot R hat minus P. Yeah, I'm sorry, I'm not writing that on my equation sheet. Infinite line charge.
Suppose we have some lambda. We're going to say E of S,
Whatever the hell S is.
equals lambda by 2 pi
Epsilon naught.
S. And why would we not just say R hat to say radially outwards?
Instead of writing words.
Doesn't make any sense. V of S minus V of S naught, which usually is like infinity or some reference point. Lambda over 2 pi epsilon naught.
ln
S naught by S.
Okay.
Moving on. A ring of R, comma, Q. Oh, radius A.
Comma Q.
Shoot.
Okay. We made it work. We made it work. On axis. What do you mean disk on axis? Like if your point is on the axis? Yeah, if your point is in the z direction, right? If you have some disk at the origin, on the xy plane, you have a disk in the xy plane, then your z on the z-axis, a point on the z-axis. I mean, all points are on the axis for this exam. I know that to be true. On axis, we'll write it anyways. V of z Equals k.
1 over 4 pi epsilon naught.
Big Q
Over R. Why don't we just do cursive R?
Our cursive R is r squared plus z squared.
But I guess we defined its radius as A for some reason, bro. Gosh, what an idiot.
Why? Okay, now I'm actually pissed.
Why did we do this?
Ring, okay.
The E in the Z direction, which is the only accumulation of E,
Is the z direction.
is QZ over V squared plus A squared to the 3 by 2.
Yeah,
I knew both of these things already, so
it's kind of trivial, but
a disk of radius R, comma sigma on axis again. V of Z equals sigma over 2 epsilon naught.
I almost just wrote 3 by accident. Would have cooked me, bro. I've made it so far.
without writing any mistakes. Minus the absolute value of z. Comma. The electric field in the z direction is going to equal sigma over 2 epsilon naught. Minus z r squared plus z squared. Comma, as r goes to infinity, we have e equals sigma over 2 epsilon, which is just clearly obvious. You have 0 in the denominator, and we just go to 1 minus 0. Okay, infinite sheet. We're gonna have E equals sigma over 2 epsilon naught normal to the surface. So we're just pointing out the area. Yeah, in either direction actually. The E above minus E below is going to equal sigma over epsilon naught, I think. 2 sheets plus or minus sigma E between equals sigma over 2 epsilon naught. What time is it? Damn. Spherical shell. Of sigma and big R. We have En is 0, of course. E out is, let's see if I can remember it off the top of my head. Outside is gonna be, I mean, do we want to just use Gauss's law? Sure, we'll use Gauss's law. So, E, what's the area of a sphere? Wait, spherical shell, yeah. Okay, area is gonna be 2 pi. Wait, what is the area of a sphere? 4 pi r squared? And sigma already equals 4 pi little r squared. So whatever our Gaussian surface is. So we're just gonna have sigma r squared over big R squared epsilon. Wait, no. No, sigma big R squared over little r squared epsilon naught. I'm a G, bro. Obviously have it memorized, bro. How many times I've done that question? Thank God I didn't write it though, because if I was wrong, bro, I would have been so cooked. If I was wrong, I would have been so cooked. I have no eraser, bro.
Bro, I'm making easy work. This is so light, bro. My equation sheet has so much space left, bro. My equation sheet has so much space, bro. Like, I'm actually, like, I'm so chilling. Like, it's actually insane. This thing looks good, bro. Alright, chat break, maybe? Make sure the pen doesn't bleed onto the back. Yeah, I checked that. Yeah, it doesn't bleed badly. Let me look at it with the light. Okay, well, if there's light, it bleeds through. If there's light, it bleeds through. Do you think it's worth going back to school for an undergrad at 25? Yeah, 25's young, bro. I know tons of people that go at, like, at higher ages. I mean, people get their high school degree at, like, 30 and stuff. Right? What's the saying? It's like, the best time to do something was obviously in the past, but the second best time to do it is now. Right? Like, the best time to go to university is when you graduate high school. The second best time is whatever time it is now, however old you are now. Right? I mean, if you don't go now, then you're not gonna be worse off going later than now, but it's like, it's the best opportunity. The perfect time to start is now. Wait, what is the saying? There's a saying. It says, like, oh, the perfect conditions to start are to start, right? Is that what it is? Does someone have my Twitter? I tweeted it once. I have my Twitter, don't worry. The perfect... oh, here, I think it's in this one. I can't find it. I can't find my tweet. I don't think I must not have tweeted it, maybe. Oh, you know what I did? I texted it to Abakar once. He's the GOAT. Ow. I don't know why I said ow, actually. Oh, I said, never wait for the perfect situation to start. The purpose situation is the one you start in. You know what that means, bro? Never wait for the perfect situation to start. The perfect situation is the one that you start in. Right? I mean, that means so many different things. But most importantly, it's like, the perfect time to start is just now. Or like when you start. Like, that's it. You start at 25, that is the perfect time to start. Can you speak Japanese? A little bit. What do they say? Like, how do you say a little bit? Gosh damn. How do you say a little bit in Japanese? Un poco? No, I actually do kind of know. It's like something. Nah, not Sakoshi, bro. I do know Sakoshi though, but I don't know. They be saying, yeah. What does that say? Kyoto. Yeah, Kyoto. Yeah, Moshi Moshi, Moto Moto. That's Kyoto, right? Wait, why did you... Oh, tsu? Oh, chotsuto? What is that? I've never heard that, actually. Choto? Wait, why'd you use that? Why'd you use... Oh, that's not Su, that's your, the vowel, the extended vowel. Yeah, Choto.
I used to know how to say I speak a little Japanese, bro. I'm so rusty. What? Bro, I used to know how to say like I'm learning Japanese. Like I know a little Japanese. I'm still learning. Okay, once I get like a refresher, I'll know how to say it again. It's kind of cheating. Bro, the thing is, I always do my Japanese studying in temporary chats. It's cooked. Bro, I used to be able to have like full-on conversations. Oh, Hanasimas? Yeah, Hanasimas. Yeah, that is actually what I used to say, I think. Nihongo sukoshi hanasemasu. No, I used to say choto. Oh, extended consonant, not vowel. Nihongo choto hanasemasu. No, that's not what I used to say, bro. Whatever. I speak a little bit of Japanese, bro. Why? You speak Japanese? You wanna have a conversation in Japanese? I love speaking Japanese. You take any sort of medication, like for anxiety? No. I'm very fortunate to not have any anxiety problems ever. Uniform sphere. I just had a typo with my pen. So we have rho and big R. I learned a bit, but I stopped. Yeah, me too, bro. I've also been watching dub recently, which is even worse. But I did just finish. I mean, I watch sub a lot too, but. Rho R over 3 epsilon naught. What the hell? I've never seen it written like that, bro. Who writes in terms of rho? Usually it's like in terms of total charge Q or Q enclosed with Gauss's law. Right? Rho R cubed over 3 epsilon naught R squared. Uniform cylinder. With rho, comma A. I've actually like never seen this written in terms of rho over 2 epsilon. I always see it in terms of the area and Q enclosed.
Coaxial.
With an inner sphere or cylinder with rho.
And the outer
Shell of B.
with some sigma, right? Shouldn't B have sigma?
Neutral, so 0.
S is less than A. E equals
A is less than S is less than B.
we need to add cylindrical shell onto this as well.
Because we've done cylindrical shell room. So it not being on here is kind of strange.
Okay.
My hands are sweaty, bro. Knees weak, arms are heavy. Mom's spaghetti.
Okay, chill.
Grounded plane.
Charge Q at a height A.
Forces image minus Q.
Minus A, right?
With F on Q
Equals.
Q squared, obviously, the minus is
Cancel out.
16 pi
Epsilon naught.
A squared.
Opposite pair plus minus Q separated by D on x-axis, field on z-axis.
Yeah, so you're mirroring both charges. They're on a line. So you're gonna have a charge y at plus Q plus A separated by distance D. So A minus D. We charge plus Q at A, minus Q at what is that?
Minus Q at A minus D.
You have a charge Q at A minus D. No, A plus D plus A minus D.
A plus D is 2D.
If you assume D, the distance between the charges, and the distance between the origin and the first charge is also D. Yeah, because you need the other side. What is it talking about? It's just making stuff up, bro.
Okay, I literally have this question written out. Method, here. Method of images. Now, E does not have any dependence on cursive R. They're just point charges, bro. Why is there a cursive R here? Oh, not any of these. Why would there be a z squared plus d by 2 squared? I'm confused. Opposite pair plus or minus q. Oh, this is not for images anymore. That's what it's saying. This is for like question 1. Wait, field on z-axis? What do you mean field? This is question 1, yeah? Oh, fuck. Dude, this thing is wicked annoying, bro. That's question 1. Yeah, QD R cubed? Yeah, QT over. Okay, so this is question 1. Yeah, see? That's crazy. I know exactly what question it is on exactly what homework. Oh, that's bad. Why do I have the homework assignments completely memorized? Right. Let's assume this is d by 2. This is minus d by 2. We would charge q at d by 2, at minus d by 2. And minus q at positive d by 2. And we have some point, a distance z away. Right. Then we say the E field at z is measured by this point. Or is measured by this fraction here. We have k, 1 over 4 pi epsilon naught. QD over cursive R cubed in the, well, in whatever direction. Let's define our axes. Say this is the x-axis. Oh no, this is the z-axis. Oh crap, I just messed up my thing. This is the x-axis. The accumulation of charges is only in the z direction, or the x direction, sorry, that's why I got confused. Because typically it's only in the z direction, but in this case it's obviously only in the x direction. Okay, so conductors. This is section 3. Conductors. These are electrostatic but oh my gosh, bro, this is bad. I just made like 5 typos. It looks like when like the AI generates images and it tries to generate text in the images. That's how bad what I just wrote was. It's like not even, I don't know what that is. It's because I was thinking of something else while I was writing. And so it cuts me. Dude, now I'm doing it again, but actually in a place that matters. I just wrote another semicolon, bro. Just outside what? Tangential. Just outside of a conductor, radially outward, sigma over epsilon naught.
That might be true.
I don't really remember. How do you spell cavities? Unless there's some charge. Oh.
Okay, it states that.
Plusky.
Yeah. Okay, let's do boundary conditions. So, number 4, boundary conditions. Now we're getting into like really dangerous left-handed area because I'm writing on the right side of the sheet, so I gotta put my palm over all of the other writing. Should I wear like a glove? Should I get a glove?
Do I have gloves?
Is that something that I have? Alex P, bro, what's up, bro? When are you coming to my school? Are you still in high school, bro? When are you coming to Illinois, bro? Okay, boundary conditions claims it can take up 3 lines. We're about to see if that's true. Boundary. Potential. Continuous. No surface dipole sheet, bro? What the hell does that even mean? I've never used the boundary conditions. I'm pretty sure boundary conditions are not on this exam. Like 900% sure, actually. But we'll write them for rigor.
What is this E above? Oh, E total equals E below. Yeah, that's right. Obviously. Everyone knows that's true. How many lines do we need for capacitance? 1, 2, 3, 4, 5?
1, 2, 3, 4, 5.
It should be 5 lines. Oh, crap. Okay, this is 100% not on the exam, but I'll write it because GPT says I need it. This is like physics 212, bro. This is like intro stuff. Q delta V, like, alright, bro. To add some resistors while we're at it. What? What is A? Oh, area with a gap D. Area A with gap D. C equals one by K. But we'll just try. It's easier to not write a fraction. Oh no. I just wrote the wrong equation in the wrong place. Shoot. Okay, this is for a spherical capacitor. Spherical capacitor. With A is less than B. So parallel plates, we have C approximately equals epsilon naught A over D. No fringing. I have no idea what that means. Coaxial. Also with A is less than B. C by L equals C prime equals 2 pi epsilon naught ln of B over A. I should write a picture for this one. This is homework 3. Question. Homework 3 question. Something. Let me see. Where's question? This is homework 3. Where's homework 3? Oh, homework. Yeah. Homework 3. Oh, I'm wrong. I think. It's homework 4? I can't. Oh, yeah, it is. Right here. Frick. Homework 4, question 1. Gosh damn it. I was all sorts of wrong. Yeah, let me draw a picture.
So we have this cylinder A with the outside cylinder covering it.
And the middle one's filled in. Okay. Let's move on. Yeah, I'm confused how it can just have, it can say energy, pressure, work, and not include anything about work. Okay.
Field energy density.
U
Equals 1/2.
What time is it?
Oh, it's only 8. I thought it was 9 for some reason. I do need to go to bed soon, but I thought it was 9. If it was, I thought like I was actually kind of stressing because at 9, like I actually do need to go to bed because then my
Exam's only in 12 hours.
You know how much sleep I need, bro? And I still have to watch like 3 episodes of Dawn to Dawn. Like, this is like I just have things that have to get done.
Electrostatic pressure.
On a conductor.
You actually do need to know the electrostatic pressure because it's related to. Oh no, it's related to what exactly?
Oh look, this is perfect because I drew this picture. Let's say A has Q plus and B has Q minus.
Okay. The thing that I'm looking for is electrostatic pressure, which I remember this. There's only one question on all of the homeworks that dealt with electrostatic pressure. Work is up. Work is up. Yeah, so electrostatic pressure is here. No, that's rho. Electrostatic pressure. Where is pressure? Yes, force equals 1 over. Yeah, okay, this is when we did this question, I thought. Oh, force. So we did force per unit length. What chapter is this? 2.5. Oh, so this is homework 1. Yeah, because remember we did force per unit length? And I was like, why are we doing force per unit length? And then it ended up being the electrostatic pressure, actually. Yeah, homework 1. Okay, so... Wait, no, this is in conductors, so this is actually past homework 1. Yeah, homework 1 is just a bunch of nonsense. Electrostatic pressure. Oh, you know what question it was? Oh my gosh, wait, okay. And I was like, bro, in my reasoning, it was so stupid. I said, this might seem like the answer, but in all actuality, this answer has nothing to do with the final answer. I wrote that in the explanation. I was like, I wrote that, remember? I know exactly what it looks like, so I'll recognize. Yes. Wait. No. Yes, here. Yes. This is it. This is it. Yeah, see, careful as this is not the final answer or the answer at all. The area is not the area of a sphere or even a hemisphere for that matter. Oh, this is when you split the two things in half and calculate the force between them. Yeah. And we had to use that electrostatic. Yeah, force per unit area, otherwise known as the electrostatic potential. Oh, not otherwise known. They relate to each other somehow. Oh, hemispheres. It's right here. Oh, idiot. Okay. I didn't realize that. Sphere. Force between hemispheres. Radius r with total charge q. F equals q squared by 32 pi epsilon naught big R squared. And this is because we use the fact that force equals force per unit area. Equals sigma squared over 2 epsilon naught. In the n hat direction. Yeah, okay. Again, we know that the force per unit area is F by A. So F equals, yeah, C, and we use the biggest reason that I had to write this was because we wrote the area of the sphere. Right. Equals big F by A. And so in the hemisphere situation, this is A with respect to Z, which is just a circle.
or a disc?
Disc. A disc is better because you're. Well, no, you're not. You're not assuming any thickness actually. Okay, we're still in work, so let's just make let's just write work in big, pretty big. Okay. Move test charge Q. A to B. Quasi-static. How do you spell quasi? Quasi-static, comma, min work. Work equals the interval from A to B of F dot DL equals minus Q, big Q, minus big Q from A to B, E dot DL, both vectors, obviously, because you know dot products, equals Q from VB to VA. Or, well, I guess that's just from A to B, but path independent. The good thing about like writing with your hands, bro, is like I can make anything. Like in LaTeX, I'm constrained by like everything that is defined. But like I can in real life just write anything. Like I'm writing all these arrows and stuff. Like these arrows are just like completely like I could not do that in LaTeX, bro. I bet you can, but like I'm not a pro. I'm not good enough yet to do it. R is a vector. Why does I have to be less than J? It doesn't make any sense. Is this like when it says V of R, is that just saying like the potential difference? Where are we even at here? Out here. Is this just saying like the potential difference? QV, like V of R is just the potential difference between like the 2 points of interest. If you set the reference point at infinity, yeah, okay, that's fine. That also makes sense. R2. Wait, what is RI again? V of R, B of R? The potential on R3. Okay, the work, so if you have two charges existing in a region, the work to bring R3 into it will have the voltage from 1, the superposition of the voltage of 1 and 2 times the charge of 3. Is that what that's saying? Where's JPD? Okay. Nah, I'm in uni. I'm going to UIUC October 24th for Halla Weekend. How's it going? It's going good. 25th. Oh, that's fire. What made you start up stream? I'm just, I have an exam tomorrow. I don't know. Yeah, Alex, I'm gonna be here, bro. You wanna go to Cam's or something, bro? I don't know what I'm gonna be for Halloween though. The meaning of V of R. Excellent question. Yes, exactly. So yes, I'm right. Is the electric potential at the position of charge Qi due to all the other charges, not including Qi itself? Okay. equals what? What is backslash KC? Yo, what is backslash KC, bro? What is it trying to say? Whatever. Let me find some Q3 and 1-3 and 2-3 and 1-3. Okay, Q3, Q1, plus, yeah, Q2, easy peasy lemon squeezy, bro. I'm down, yeah, me too, bro. Cams is a bar. Alex, add me on, follow me on Instagram. I do kind of struggle with my 2 times tables, I'm not gonna lie. I do actually like my, bro, for some reason, like just quick addition and multiplication and stuff, especially like subtraction and division, I'm cooked. Like I'm actually straight cooked when it comes to that stuff.
I mean, I would say I'm probably better than like the average person, but like most people in like my major and stuff are like really good at that. I feel like.
Like for my major and like for the people I'm around, I feel like I'm probably the worst out of all of them at that stuff. Especially division, bro. I actually don't even know how to do division, like dead ass. I don't know how to do long division. I just leave things as like fractions. And I can simplify the fractions and stuff, but no, I can do like division in my head, but I usually just do divided by 2 a bunch of times, or divide by like, I don't know, something that I know. What's your IG? It's Aidan Andrews with like an extra S on the back, but it's just like my name. There's an extra S on Andrews. Grounded infinite plane at z equals 0 with real q at 0, 0a, image minus q at 0, 0 minus a, ensures vx, y, 0 equals 0. Use superposition and z is greater than 0. Okay. So the potential at, I don't even get what that means. Boundary value problems. Identify reasons. Okay, that's not on. That's like for sure not on the exam. Like I'm not even gonna be lazy in my equation sheet. I'm just saying like this is legit not on the exam. The exam goes to lecture 10, 1 through 10. Oh, I guess Laplace's equation is here. Yeah, but separation of variables is really where you get like boundary conditions. Okay, fine. You're right. Let me do boundary. I'll write it. 7. This is 7. Yeah, 7. Boundary. Value.
combination of variables.
That is 100% not an exam. So 9 is uniqueness.
Let's try to write this on one line.
Oh my gosh. Given rho of R in either V or dV by N, on every boundary the electrostatic solution V is unique. Okay.
V is unique. V is unique.
IFF.
Rho of R exists. Either V Dirichlet or
Newman
with fixed charge.
fixed charge. Okay. Homework 1.4.
Oh yeah, this is nice. It's good that I have the homework questions memorized, because all I need to do is write the solutions and I actually remember what question they're from. Okay, 10 homework cues.
Yeah, this one actually screwed with me, bro. Because I tried to use, like, all these, I don't know.
Q enclosed equals 4 pi epsilon naught k r to the 5th.
Okay, well, just having that, this literally means nothing because, like, it doesn't actually give you any hints, but it actually does make me remember that to get Q, well, you can use Q, you can do, well, I would just do Gauss's law on the exam. But the first way is to do, okay, so Gauss's law, super easy. The other way to do it is to integrate, you have a double integral, r dr d theta. Wait, is it spherical? No, it's spherical, that's why. That's why on the homework, this isn't like question, this is like homework 2. I remember I did it and I was like, oh, homework 2 is light AF. And then I was doing the question, I was like, wait, why do I not remember how to do this? Oh no, it's homework 1, wow. Yeah. So it's a spherical, yeah, sphere. So you do r squared sine theta, d theta d phi. Oh, r squared d r d theta d phi. Because r is not constant. Yeah, why don't I write that down? Q enclosed equals this equation. Where is it? Rho, integral rho d tau.
which we had r squared sine theta d theta, or dr d theta d phi.
Okay, question. Next. Oh, this is a good answer to have.
Yeah, this is a good answer to have. Sphere
R plus. Wait, why don't I just draw an image? This is this one. Let me find the picture. No, this one. Let's see.
Okay, yeah, I'm just gonna draw an image. So we have some spheres filled in here. We have some big here. We have
Big R.
is less than A, is less than B.
Because this one was super weird.
Sigma R equal.
Oh, because these are conductors. Oh no, these aren't conductors. If it was conductor, you'd have QA plus QB. Wait, no, that's if it was... No, that is a conductor. Wait, what? These are both conductors. Yeah, metal sphere. We have minus Q accumulating. Oh, because there's no cavities. Plus Q accumulating on the outside. So R is going to have plus Q, minus Q, plus Q. Yeah. Easy peasy. Hey, I researched at Berkeley how many DMs have you gotten because of that a little while ago. Let me follow you back on Instagram. Yeah, like 19 minutes. Yeah, instrument. I gotta be asleep by, or I gotta be done by 9 p.m. because I gotta shower. I have to watch Dawn to Dawn. Like, I just have some things that I have to do. It kind of sucks. Wait, quick reference table is like a repeat of everything we have. Okay, I'm done writing stuff on this equation sheet. Like, there's nothing I need to write, bro. I already know all this stuff, bro. Easily calculatable. I guess I'll just write it real quick. Bro, why is my pen tweaking now? Shoot. An idiot. Yo, my pen is like dry. It was so good just like 1 second ago. Do I have to rotate it or something?
it's the paper.
Something's wrong with the paper right here. Two cavities. I know how the cavities are so easy.
Oh, yeah. Let me do the VAV, bro. That actually cooked me. I had no idea what was going on. Or not cooked me. Because, like, you don't really think about, like, you just add the Q and close.
Yeah, you just took V center was just V. Bro, look at this. Look at this. These are my notes. Hold on, let me. These are my. This is my equation. This is my equation sheet for the exam. Hold on, let me make it big. Look at that. I have free space at the bottom, and then also the back is completely empty. I'm thinking I'm actually just gonna use the one page for this exam, and then I'm gonna use the other page for the next exam. Because on the final, you're only allowed one double-sided piece of paper, right? So it's stupid to make 4 sides of paper throughout this. Oh, 6 with 3 exams. 6 throughout the whole paper, or throughout the whole semester, when I could just continue filling this one up. I'm just making excuses though to not write more stuff down. Bro, I know this shit off the top of my head. Like, I don't need an equation sheet, bro. I'm gonna go print downstairs this one. And then I also need to work on some stuff. Okay, I have work that I need to do, but what I'm gonna do is I'm gonna shower. Yeah, I might just push my work off till tomorrow though. That kind of sounds better.
Yeah, but then I'm gonna have a ton of work to do tomorrow. Bro, I still haven't done my applications.
Gosh. Yeah, let me just send the info to first. Oh, I guess I can show this. No, not that, bro. Yeah, this goated ad website. Alright, that was corny, bro. I'm sorry. How do you spell forego? Wait, how do you spell forego? Is it just F-O-R-G-R? Or G-O? Omit, yeah, it's just O. Let me get my go-to website again. you guys can't even see what I'm looking at. I'm rebooted. Look, I'm looking at my goated website. My goated resume? It's like half updated. Let me actually update it a little bit more. I just need to open the one file. Nah, fine. We won't write it because I'm technically not in Chem Lab yet. Yeah, AI research. Oh, this is... Okay, well, let me make this more accurate, bro, because this is low-key cheat. This is low-key capping. Not crop management. Let's just say data management. And this is true, but I should really... Why would we put RAG pipeline and vector embeddings? RAG pipeline. What else do we have other than like RAG, agents? Well, just because agents encompasses like all the functionality, bro. Like just adding like one agent is like, wow. Like, wow. Yeah, like managing integrations isn't really that cool. We don't need to say RAG pipeline and vector embeddings. That's not necessary. Custom agents. We don't need to say vector embeddings. And we're also switching off of QDRAM.
take your dream.
Yeah, we'll just say vector.
For agriculture.
Okay, but now we don't need to say RAG pipeline or vector embeddings. That's implied with document processing. It has so much functionality. It's just like, what is worth putting on your resume? Like, it's really straightforward, most of the stuff. Like building Google Drive integration. Let's just say integration.